Welcome everyone to the 2026 Schock Prize Symposium. And let me first and foremost welcome Bas van Fraassen, our laureate for logic and philosophy this year. And let me also, welcome the four speakers. It's great that you're all here, and I'm really looking forward to a fantastic event, I think. So let's start right away. Let me ask Bas van Fraassen to give his laureate lecture.
Thank you, Richard, and I want to thank you very much for the organization of the symposium. I'm very happy that the Academy, so I'm thanking the Academy and you personally for this organization of the symposium and everyone who takes part in it. I'm going to give a paper that has two parts. The first part is a narrative, and the second part is an argument. And in the first part, I will bring up, as the title suggests, a number of voices from the past. So, beginning in not very far in the past, in 1970, a paper by Paul Feyerabend, philosophy of science, a subject that I suppose we can all get the innuendo. But it's also true. The title is true. And the paper in which he discusses a certain part of the past, in fact, the time around 1900, when there were a number of very important physicists and mathematicians who were at the same time philosophers, right? Who were very philosophical. I'm going to refer to each of these people in the course of the narrative. I would have liked to show you some photos, but perhaps you can just imagine photos of each of these. And they're all more or less alike. They're all very traditional gentlemen, so they all look alike. But these are the ones whom I will take up. And I say 1900 as the specific year as the point of reference, but of course the papers by Mach are like 30 years before that, and so on. Now, in the 70s, I felt that I had a great difficulty. You know, I had come into philosophy of science because when I was an undergraduate, I read Hans Reichenbach, and I wanted to be an empiricist just like Reichenbach. Then, one of my teachers was Wilfrid Sellers, the great scientific realist, and I was caught between two camps. I didn't know how to answer the arguments by Wilfrid Sellers. But then something worse, from my point of view. Two young philosophers, Richard Boyd and Michael Gardner, gave, in effect, a proof, yes, I think something that counted as a proof, that it was not possible to make a distinction between the empirical content of a theory and the whole theory. That trying to separate out the empirical part of the theory from the entire story about the world was impossible. And the proof, I'll just sketch it a little bit. It has a lot to do with auxiliary hypothesis, which, for the most part, may still be unknown. A theory doesn't have any, and typically, a theory doesn't have empirical consequences without auxiliary hypotheses. For example, the background conditions where you are trying to make your predictions, or hypotheses about the world that are separate from the theory. Now, some of those hypotheses are not there at the moment. They will arrive later. We don't know what they are. Can we beforehand restrict the kind of hypothesis that will be allowed? And they argue that no, it is really impossible. on the other hand, if there's no restriction, no logical restriction you can put on the auxiliary hypotheses, then it's a very quick two-step proof that there is no distinction between the theory and its empirical content. Now, I would like to, they make it very plausible with examples, and I think the best example actually is the one by Poincaré. There is no way to measure the absolute motion of the Earth if all you have is Newtonian physics, right? But Poincaré pointed out that if you add, as an auxiliary hypothesis, 19th century electromagnetic theory, then part of that theory is that if two charges, collective charges, are moving, they create a magnetic field and they start attracting each other. Now, take two charges, keep them at rest on the Earth. Yeah, but listen, the Earth is moving. So they will begin to attract each other, and in principle this can be measured, and that will measure the velocity of the Earth, the absolute velocity. Whereas before it seemed to be just something non-empirical totally. Then in the 19th century, with this added, it becomes an empirical question. Now, of course, we all know that the answer turned out to be no, right? Miles-Morley experiments show that, in fact, that this effect is not happening. But it's a good example, a good historical example, in the context of 19th century science. So this is the sort of thing that can happen. I mean, nobody in Newton's time could have predicted this or have thought of what that could be. It was not conceivable at the time. And so we can be in the same position today with any theory. Now, the one thing that I want to point out, and that's going to matter, is that when they give their proof, they are speaking within the what was called at the time, the received view of scientific theories, which is basically following the definition that a logician would give. A theory is a set of sentences that is deductively closed, right? And within that received view also, any way of making the distinction between what is empirical and not was put into the vocabulary, so that some terms are ones that the application can be checked by observation. And so I'm quoting this from Gardner. He gives as a definition, two theories are observationally equivalent if those theorems which are directly testable by observation are the same in the two theories. Then they're empirically equivalent, right? And then the conclusion of the proof is, if they are empirically equivalent, they are identical. Okay. So there's no hope for an empiricist if that's the case. Right? Well, this received view is exactly what was disappearing at the time, just around the year 1970, right? And the semantic view was beginning to take its place. They had framed their problem within the received view, and now I'm not going to talk a great deal about the semantic approach. I mean, I hope that some of you are to some extent familiar with it, but there's been so much written and said about it that I will not say very much. But there's a recent paper by David Wallace 4 years ago, which has a very good informal exposition of the semantic approach in his own terms. He calls it the mathematics first approach. He distinguishes it from the language first, which is basically the received view, and the math first, as he says himself, is the semantic view. So that's a very good exposition that he gives, and I like the term math first very much. When I was reading it, I thought, oh, I like this paper so much. I like this paper so much, all right? And well, then I remembered something about my teacher, Wilfrid Sellers. Sellers was a very professorial professor, very thoughtful, very calm. Right? one of the students asked him about the views of another philosopher. And he said, yes, 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 his views are very profound. In fact, they are much like mine. So, well, some of David Wallace's views are very profound. Right. Mathematics first, yes, that is a good way to say that's what the approach is. Don't think of the theory, first of all, as a set of sentences. Now, this semantic view developed over a period of about 35 years. The main sources here, when Tarski makes the distinction between deductive consequence and logical consequence, that was step 2 semantics, right? Berkheim von Neumann, the logic of quantum mechanics, with the message that, look, logic is not up to the logician when it comes to logic of scientific theories. Weil's paper, The Ghost of Modality, and perhaps the clearest by Beth, The Semantics of Physical Theories. But the only one that I'll say something about is Weil, because Weil's paper is not very well known. It appeared at the wrong time in the wrong place, so to speak, to get any attention from analytic philosophers. But it is, in retrospect, looking at it in retrospect, I would say this is the crucial moment when there was a clear insight in the range and applicability of the semantic approach. So what Weil said was, let us try a unified analysis of 4 logics. Modal logic, logic of necessity and possibility, developed by McCall and Lewis. Intuitionistic logic, as presented by Heiting. Quantum logic, Berkhoff and von Neumann. And probability logic from Reichenbach. Now, I'm not going to say that he was successful. Okay, I won't say it is a totally successful paper. But if you look at it with eyes from today, you see it's all there. So the basic sort of model for the different analyses has a structure that the sentences are connected with propositional functions defined on a certain space. His own preferred example or guiding example of the points in this space are the possible physical states, or possible states of a physical system, right? He didn't think of calling them possible worlds. If he had, then we would be in the usual bailiwick, right? Okay, now my epiphany, right? What did this do for the problem that Boyd and Gardner had set? How did the semantic approach give me the answer that I needed? Well, 1974, I was on sabbatical. I'm sorry that the pictures I took away here, okay. My girlfriend and I found an old car and an old tent, and we traveled for the year around Europe and North Africa. I mean, those were hippie days, right? And there was no internet, no computers. I had a big suitcase full of preprints and off-prints, things that I had to study, to work on, and they included 2 papers by Clark Gilmore. And somewhere that fall, camping, I read those, and it was a kind of breakthrough for me to read those. The point of the first paper is that the local geometry, this was about relativistic models, cosmological models. The local geometry does not determine the global topology. So what you measure, of course, is always local. So all the possible data from measurements will only give you the local geometry, and that will be compatible with different global geometries. Right? He made a similar point in the second paper about agreement just on the past cones of specific path cones of specific space-time points. Suppose that on every one of them, the two agree. Well, the global topology may still be different. Okay. Now, the first thing, of course, you would think here is, oh, underdetermination, is he just making a point about underdetermination? No, well, no, what struck me was here I saw the way in which I could give an answer to Boyd and Gardner, that this showed how to define empirical adequacy and empirical content in a way that was quite different from the way they did it with sets of sentences and theorems and observation terms. The relation between the models of the theory and the phenomena is what counts. It's the empirical adequacy of a theory will have to be defined in terms of the relation between the models of the theory and the phenomena that are actual, right? And what the scientist is doing on this picture is he is creating beautiful, unified mathematical structures, and the phenomena have to fit in those structures. The phenomena are local, they are finite, they are small, they are chaotic. But if the scientist succeeds, they fit into this beautifully unified picture, right? And the important point is that the way in which the phenomena are pictured has to fit into the world as pictured by the theory. So that gave me a definition of empirical adequacy, which allowed for this distinction that I could see in the examples of Glimmer, that being empirically adequate does not imply truth. Right? The empirical content is not the whole of the theory. Right? And so in those terms, then, I was able to define this position of constructive empiricism. It's a very short theory. It just has basically three principles, right? With of course, elaboration to go with it. First of all, it characterizes science in terms of its aim. The aim is not to create true theories, but to create empirically adequate theories. And so a corollary, the acceptance of a theory means belief that the theory is successful, right? So the only belief that's involved is belief that the theory is empirically adequate. Now, acceptance of a theory is going to involve more than just this particular belief. There are pragmatic aspects to it. First of all, the scientist who accepts the theory will then immerse himself in the world picture of the theory in order to work within that. And even us laymen, we accept the theory, we will think that any new phenomenon has to be confronted within the terms of that theory. And the theories, we require them to be quite audacious, to be informative. You know, if all you want is truth, that's cheap. Just speak tautologies. The same for empirical adequacy. It's just as cheap as truth in that respect. I mean, it is the bottom line, the bottom criterion of success. Truth for the scientific realist, empirical adequacy for the constructive empiricist, but by itself, it is much too weak as a characterization of what we want and what we aim for, right? So what we will accept is, there's no point in accepting a tautology. Okay. Now, the definition of empirical adequacy, as I said, it's about the relation between the model and the phenomena. Well, the phenomena are modeled by means of results of measurements, right? A collection of results of measurements will give you a data model. And that has to fit in the model that the theory provides. Now, oh, no, sorry. There is a danger here that this will just be seen as a kind of instrumentalism. And Harald Wiltshire pointed this out to me. And I realize, I can imagine why. Because if empirical adequacy is what matters, and if it's just about relation between two kinds of structures, the mathematical model created by the scientist and the model that represents the phenomenon, and the relation between these two mathematical structures is mathematical, what has happened to meaning? What has happened to talk about atoms and force fields and quarks and, isn't it just a kind of black box now with, just bits of mathematics playing with each other, right? Well, my answer is this. Scientific models are mathematical structures, but they are mathematical structures just in the sense that the Mona Lisa is a painted piece of wood. That's true. The Mona Lisa is a painted piece of wood. And we could talk more about it. Its dimensions are about 53 by 73 centimeters. There's a certain distribution of colors on the surface. Yeah, but no, that's not the point. The Mona Lisa is a representation. It's the representation of a young woman with an enigmatic smile. This is what is true about a scientific model too. It's a mathematical structure, but it's a representation of the world or of the system that is the target. And the data model is a representation. It's a mathematical structure, but it's a representation of the phenomenon. Right? So the real way to think of the semantic approach is to say that it is a theory, or it's a view of science as representation. Right? And in this, we go back 70 years to the period around 1900, to these physicist philosophers or philosopher-physicists who all talked in terms of images, pictures. Okay. It was the build theory is the theory that is the theory of science as representation, right? Build representation, right? And all of these talk in those terms when they talk about scientific theories and scientific achievements. The clearest statement is at the beginning of Hertz's Principles of Mechanics. Now, we form ourselves images, scheinbilder, right? Or symbols of external objects. The images that we're speaking of are our conceptions, Vorstellungen, representations, right? Now, they didn't use the word model in the way we do. In 1904, Boltzmann wrote an article for the British Encyclopedia about models. It was entirely about physical models, about tabletop models. The word model was only used for physical instantiations, right? I don't see them talking any differently. Today, we do not speak that way. Today, mathematical solutions of a theory we call models, right? First place where I noticed, I'm not a historian, but in that paper by Weil, The Ghost of Modality, at some point he is referring to mathematical structures as models, but he begins by putting it in quotation marks. It's a quote, model, quote, okay? And of course, after that, the use has changed, and we just say model, for mathematical structures. So, and then Hertz spells out the exact relation that he says there should be between the pictures that are the theory and what the theory is about. These pictures, with the things, they are in conformity in one important respect. The necessary consequence of the images, builder, are always the images of the necessary consequence in nature of the things that are pictured. It's a symmetry diagram, right? So the question of empirical adequacy for the theory is exactly the question whether we can picture the phenomena as part of the world as that world is pictured by the theory. So that's why I said voices from the past, because it's a matter of realizing that it happened. But what happened was that we returned after leaving the logical positivist tradition behind. We returned to the build theory of science. Okay, well, this was my narrative, right? Partly about lots of other philosophers, but partly really personal, because there was a moment when I felt I sort of broke through and understood what how I should frame an empiricist view. Now, this was not left without criticism. At first, I thought that what I could at least do is leave epistemology aside. That really this was not about epistemology. I was presenting a view of what science is, right? Whereas epistemology is about knowledge and belief and how to warrant belief and how to arrive from the data, from belief in the data to belief in the theory and so on. Now, and actual scientific realists never liked my way of setting out the terms. I said, constructive empiricism says that the aim of science is empirical adequacy. Scientific realism is the contrary. It says the aim of science is true theories, right? If they mention it all, it seems to be just trivial to them, I think. They don't think in those terms. They think in terms of, oh, well, what is true? And how do we arrive at the truth? That is the main concern of scientific realists in practice. And so sometimes we have just been talking past each other. I have to emphasize that constructive empiricism, that this view of science doesn't imply anything either about whether theories are true, whether our best theories are true or not, okay? And it implies nothing about how to arrive at a belief that something is true, okay? Acceptance involves belief by definition, but then a person who accepts a scientific theory can have lots of other beliefs. He can believe the theory is false, or he can believe the theory is true, or something else. But any extra beliefs like that are supererogatory from the point of view of acceptance. But there's no such thing as a counsel to be agnostic, for example. Not at all. Right? They just say that within the context of scientific theorizing, scientific enterprise, acceptance of the theory just involves limited belief. Okay. So I thought that I could stay away from that kind of subjects, because since I hadn't really implied anything about it, but of course that was impossible. Right? And in fact, it's a challenge that I could not possibly avoid, because maybe constructive empiricism will just be totally irrelevant if they are right about how to arrive at the truth about the blueprint of the world. So, I mean, think about how a pharmaceutical company can surely establish beyond any reasonable doubt that if you take aspirin, your headache goes away. Right? That's an empirical hypothesis, and statistical confirmation is something very well studied and developed. Now, if it's exactly the same with scientific theories overall, well then, I think this point about only having limited belief when you accept them becomes sort of irrelevant. Right? So I had to take that on. I mean, that was a challenge within epistemology that I could not avoid. And I tried to refute the false hopes of traditional epistemology. But what I will focus on here, in the argument I'm going to give, is this. Experimental support for a theory is very important, but it's not the same as confirmation. They are two different subjects. So let me begin by what I think is a completely mistaken idea, what I call the well-founded measurement myth. And this is not usually stated in any way. You see it only between the lines mostly. For example, in David Wallace's paper, he talks about how predictions are not usually testable with the naked eye. Of course, people use measurement apparatus, measurement instruments, and the design of those instruments, of course, is something that is done on the basis of scientific theory. But he says, from a theory other than that is being tested. Okay? So the measurement is designed by a theory other than the one being tested. And he gives examples, like he says, models of atomic structure know nothing of light. Well, I think we could dispute that maybe, but what he's making the point is that this theory about atomic structure is being tested with measurements based on a theory about light, right? And the two theories are distinct. So the well-founded measurement myth is this, that there is much measurement is theory guided, but there's a virtuous regress. Okay? For example, in biology, you may rely on chemistry to make measurements. In chemistry, you might rely on atomic physics when you design your instruments. In atomic physics, you'll rely on classical physics and classical optics when you design your experimental setups. But then measurements in classical mechanics, they are just direct measurements. Or I don't know, maybe statics, whatever. But there comes a point when there's no more need to have theory-guided measurement procedures, because at some point you just have direct measurements. And so this regress goes down to bottom. There's no circularity. Okay? Is that, yes, no, that's a myth. This is a myth. This is a totally untenable myth. In the 19th century, Kirchhoff and Mach made a great attempt to establish that there is this bottom level. When I move my finger, I don't know where that is. Okay. And Mach especially is important and famous for this. He decided that the basic theoretical concepts of mechanics, force and mass, had to be given a definition that would be totally theory independent, that would rely just on empirical relationships. And specifically, he thought that the mass ratio, this is a good example, mass ratio can be defined in terms of accelerations that bodies induce in each other. Now, of course, you might already think induce sounds like a modal term, right? Anyway, this was completely unsuccessful. Okay. He worked it out in great detail and gave many proofs to show the adequacy of his definitions. But Poincaré especially was able to point out that every one of those proofs then relied on some principle of Newtonian mechanics. It was impossible to do what Mach tried to do, which is to define mass and force, the theoretical quantities of mechanics, in ways that are independent of the theory and measurement, and give measurement procedures that did not presuppose any part of the theory. Failure. Now, I mean, I'm saying so, you may not be convinced just because I say so, but that is, I think, the verdict of history, right? And if that's the case, then this myth of well-founded measurement, which I think is one of the supports for scientific realism, is actually the kind of empiricism that we have left behind. It's a defunct Machian empiricism. And one of the lessons of this particular part of history is that everyone should leave that behind, not just the empiricist. So let me dramatize this. And I can do that by going to the dispute in the 18th century between the Newtonians and the continental physicists who were still much in the Cartesian tradition. So the Reverend Atwood takes on the Cartesians. He says so in his treatise. The Cartesians, in Descartes' physics, the only quantities were kinematic, just definable in terms of spatial and temporal quantities, and they were all directly measurable, rulers and clocks. Okay. They say that when Newton introduced force and mass, he was going back to the medieval's occult qualities. Occult meaning, not visible to the eye, so to speak, right? And that they are not able to measure those quantities. And Atwood says, no, we can measure those quantities, okay? And the example he gives is to measure mass ratio. And it's a very simple setup. If you want to determine the ratio, the mass ratio between two bodies, you suspend them over a pulley. Sometimes they will just stay like this in equilibrium. Then the mass ratio is 1 to 1, right? Because they're equal. Usually one of them will go down and the other up. The accelerations are equal, but in opposite directions. Measure the accelerations and then apply this particular equation that the acceleration is proportional to one mass minus the other over one mass plus the other. And from that, you can easily calculate the mass divided by the mass of the one divided by the mass of the other. That's it. That's how you measure the mass ratio. Yes, it's true, right? But the Cartesians say, yeah, but listen, that equation, it comes from Newton's theory. You're begging the question. This is circular. And of course, they're right. That equation comes from Newton's theory. So Atwood is presupposing that the setup is a Newtonian system. The Cartesians are right. Well, they're right in this way. If you read the episode as confirmation of Newton's theory, then they are right. But at the same time, you can sure all see that this is just the kind of experimental support that the theory needs and should have. Right? Now, some philosophers have talked about theoretical nepotism, that there's a threat here of theories being able to get away with things by loading the dice. Now, let me spell out exactly what it is that Atwood does. His measurement of the mass ratio presupposes that the system is a Newtonian system. So he is presupposing at least part of Newton's theory, right? And he demonstrates that the values of the theoretical quantities can be determined from direct measurement via the theory itself. It's not confirmation, but it is crucial support. And the exact terms were spelled out by Hermann Weyl. Hermann Weyl, you probably know this, is one of my heroes, right? So in his great book about natural science and philosophy, he spells it out at a certain point. This is the requirement on a theory. To be a good theory, it has to meet this requirement. The definite value of any theoretical quantity should be in principle determined from the empirical data on the basis of theoretically posited connections. And then, here's the important empirical part, every such determination has to give the same answer. Right? I'm going to, for emphasis, I'm going to say this once more, but in a bullet list, okay? For any quantity in a theory, it has to be possible in principle to determine its value. That's crucial, right? How? From direct measurement results, because in the end, that's all you have. At the end of the day, that's what it all comes down to. But based on calculations supplied by the theory and consistent with those theoretical connections in the theory itself, then there has to be concordance. That is Weil's word, concordance. Every such determination has to yield the same result. And then non-triviality, so no nepotism, right? It's that the situation set up here must be such that if you had gotten different data, you would not have concordance in your results. See, it should be logically possible that your data could have been different and go against the theory. Otherwise, it would indeed be a self-fulfilling prophecy. Okay, now, crucial. That support is not confirmation. That kind of support is not confirmation. Support by theory-guided measurements of that sort is not confirmation. Why not? Well, I know that the word confirm, of course, has a broad sense as well as a narrow sense, different senses even. But I'm using the word confirm just in this very specific sense of making more likely to be true. Right? It's in any paper on formal epistemology always starts with it, right? Evidence E confirms property theory T exactly if the probability of T given the evidence is higher than the probability of T taken by itself. And then there's the Lockean principle. You should apportion your probability to the evidence available. Yeah, I mean, the Bayesians do not accept that, but it is at least a guide to what you should do, what you try to do. Now, the problem is this. If one theory implies another, for instance, the other may be a small part of that very same theory, then the probability of the big theory cannot be higher than the probability of the small theory. Right? That's first step in probability theory. Right? But the kind of the kind of theory relative experimental support that can be gathered will typically, in fact, be greater for the logically stronger theory. Why? Because to design measurements, to design measurement procedures, to design experiments, you have to have theoretical resources to do it. And a very small theory, right, a small part of a theory will not include those resources. So there will be no experimental support for it because you don't have enough resources to design the measurement. Right? But then a bigger theory may have these other resources. And so data can be gathered, measurement procedures can be defined, can be designed, and experimental support can be received. So probability and support go in opposite directions. Okay, now when I first mentioned this, people immediately objected something, and I should have realized the objection would be immediate. It's something like this. Okay, suppose that a theory, think of a theory growing, so it has a small part and it gets bigger and bigger, right? And as it gets bigger, you design more and more experimental procedures and you get more and more theory-guided support. And they say, well, that confirms the theory. And if anything that confirms the theory will also then confirm the first part, the part you began with, right? Well, it's not so, okay? I mean, I'm sure it's not even true in economics, but in epistemology, it is not a principle that a rising tide will lift all boats, okay? I give a simple example. This theory has two postulates. There's life on Mars, and tortoises like lettuce. And if I gather some information that makes it more likely that tortoises like lettuce, which in fact they do, that confirms, and doesn't just confirm the second part, it confirms the theory as a whole. The conjunction of the two gets a higher probability when you bring that evidence about the tortoise eating the lettuce, right? But surely postulate 1, there's life on Mars, gets its probability doesn't change. You see? So the fact that the tide is rising, right, the theory as a whole is getting confirmation, doesn't mean that that part is getting any confirmation. Right? Now, I know that this is a very simple example, and you can immediately say, oh, but there's no connection between these two postulates. So no wonder, right? And there's no relevance between the two. Yeah, right, of course. So if there's a statistical relevance between these different postulates and the postulates and the evidence, yes, in that case, the rising tide can lift the first boat as well. But that requires that there are probabilistic dependencies between them. And the important point is this. It's very easy to be confused there. If you look inside the theory, you will see all kinds of relevance because they work together, these postulates. But that doesn't matter. It is there have to be probabilistic relevance relations, correlations in the prior probability in order for there to be confirmation. Now, what about this prior? Well, I'm a liberal Bayesian, so I say, the prior is up to you. Okay? Just don't think that logic and probability theory will do it for you. Right? Okay. Well, I'm pretty well finished. I won't make a practical point. Empirical grounding is very important from a practical point of view. Remember that it means that all these theoretical quantities, their values must be possible to determine them by direct measurement. Now imagine, for instance, for Newtonian mechanics, which is still used after all, that somebody, an engineer is building a bridge, designing a bridge, building a bridge. He has to talk about the forces that the bridge has to withstand. The forces will impact the bridge, the wind, the rain, the shifting soil, and then he has to talk about the material that he's going to use, what kind of resilience it has. Now, yeah, well, this is all described in terms of forces, right, and masses. And so if there were no way to use direct measurements in order to get to the values of those quantities, he couldn't design a bridge. Right? So the practical point is that without it, you cannot even do anything. And this is my coda. So from my point of view, whether the theory is actually true, well, that's an academic question. Not saying. But if empirical grounding is achieved, then the theory and its models are going to run like a well-oiled machine. And applications in the observable level will be perfectly possible. Okay, that's it. Did I go much over time?
Absolutely not.
Oh, good.
Perfectly in time. Questions? Sebastian?
Yeah, you said your account of empirical adequacy solves basically, well, in a way, it was set up to solve the problem of the counter-argument of Boyd and Gardner.
Yes.
Now, that one relies on the auxiliary assumptions for theories.
Yes.
Where do those auxiliary assumptions occur in your account?
You see, the definition is independent of any, what should I call, epistemic procedures, okay? Mm-hmm. It is independent of whether or not any consequences have been drawn at all, because it is entirely in terms of the models that the theory has, which is determined for all time. If the theory doesn't change, the theory will never have different models, right? And the kind of models that are made of the phenomena, whatever they are. So I think for example, in this example from Poincaré, right? They were not able to design a measurement of absolute velocity. Then when electromagnetism comes along, they suddenly encounter a new phenomenon, that if charges are moving, two charges together, they are moving, they attract each other. It's a new phenomenon, okay? This phenomenon doesn't fit the original theory. So that theory was not empirically adequate. Okay? But that was true all along. That phenomenon did not fit Newtonian mechanics. Okay? And we didn't have to know it beforehand, it just was the case. You know, in a very general sense of realism, this is a realist attitude, right, that I'm taking, because I'm a common sense realist. I don't think that truth is anyway verification dependent. Does that help? Does that answer, do you think?
Well, it's still surprising that you can. It sounds like basically now the theory just is fixed, and we never consider any auxiliary assumptions any longer.
Right.
But couldn't the logic guys, the logical empiricists, also just have said, no, we're just looking at the theory. We fix it, and we don't look at any.
Well, but in that case, they themselves pointed out that there would be a clear distinction between empirical content and the theory as a whole, because they defined because if they didn't think about auxiliary hypotheses, then the empirical content of the theory is just a set of theorems that are written in observational terms. And two theories can have the same set of theorems in the observational language, but still be very different theories. So in that case, there would be a distinction between empirical equivalence and logical equivalence. You see, so then I could say, okay, fine, there is a distinction, so I could be an empiricist, and etc. The only thing is that their distinction was not really very good.
Thank you.
Yeah.
Great.
Oh, thank you. It seems that maybe this is just something that doesn't matter. But
You will have to speak out loudly.
Sorry. Maybe this is something that doesn't matter, but maybe you treat it as an invitation to kind of say why. It seemed like at the end you switched back to thinking of theories as sentences, because your examples at the end, when you started talking about the probability of a theory,
They
were all T equals a sentence. So that's slightly dissonant with what you were saying earlier, but maybe not deeply so. Maybe you could comment.
You can put models on a page. I mean, what you can put on a page is descriptions of models, right? I mean, and you may call them axioms, or so yeah, that's what you deal with there. What gets the probability is a statement, right? And the statement could be something like, all phenomena fit some models of the theory, right? Of course, that's not the way the theories are normally stated, right? Normally what you get is a number of equations that describe how the models are built. But whether you take the positivist approach or the semantic approach, in either case, a theory is something that has a truth value. And in either case, there will be a proposition that is the content of the theory, and you can define, and probability could be attached to that.
So this is like Geary's theoretical hypothesis that says. So I mean, so one comment on that is, doesn't that undermine the kind of and claim that we don't have language first? Because in order to make yourself, so you say all this stuff about not you, but David Wallace, everyone. You say this stuff about how it's a class of models, blah, blah, blah. But then, as you just said, I mean, to make that connect up with our traditional idea of theory, you have to have some hypothesis which is said in words, which is something like a model of the data approximately embeds in an empirical substructure of the theory, and that's a claim in language.
Yeah. Well, You see, I don't see how it could be otherwise. I mean, if I say that to specify a theory, you specify a class of models, that doesn't deny that the theory will be true or false. It's just that the claim will not be these models exist, or that that in mathematical heaven they all exist. That's not the claim. That's not what is true or false. Rather, for the realist, it is the proposition that the world as a whole will be in effect a model of the theory. For the empiricist, it's rather that the theory is empirically adequate. This is a proposition, right? Now, if we just say the probability of T, we mean the theory as a whole, okay? Absolutely, just in the way that the scientific realist understands it.
Further
follow-up if you...
You have a follow-up?
Well, so the other thing I was worried about is these nice theorems like if T entails T dashed, then the probability of T can't be less than the probability of T dashed. They all fail as soon as we start talking about approximate truth.
They fail when?
As soon as we talk about approximate truth.
Approximate truth.
So as soon as I say T entails T dashed,
yeah.
and now I start talking about the approximate truth and the approximate truth of T dashed, those nice probabilistic relations just don't automatically hold.
But you are reading probability in a way I wouldn't. I mean, I think probability means probability of truth, period. You can have another theory that's an approximation to the first one, but in that case, again, the probability of the new theory is the probability of its truth.
Right, but then the realist might say, but truth, simplicity is just never an issue. Like we know for sure every theory we've ever had has only ever been approximately true in some domain with respect to some features to some degree of accuracy. Anyway.
Yeah, no, but I'm only making a logical point about what probability applies to. Yeah.
Further questions? Sebastian again.
I'm wondering whether you couldn't reply to the objection there by just saying, well, we don't have to say this specific theory is true and then make it weaker and say, well, approximately so. But you say, okay, here's my new theory, and it states my old theory is approximately true. So basically what you get in the model view, it would basically be, instead of having one sharp model, you have a class of models and say one of them is true. And that seems to be then again a completely fine statement that you can assign probability.
I think
but then the objection that then it all goes out the window, doesn't follow it.
That is how I would think of it.
Okay.
You're entirely right, yes. Yeah.
Thank you.
I might step in with a question. A question about the statement that not all boats rise with the tide.
Okay. Yes.
And the argument you make is that this is plausible from a theory internal perspective, but once you go beyond the theory, it's not clear at all. And I think, on the one hand, I think that's a very important point. On the other hand, one might argue that if you have confirmation on both sides, so confirmation on the T0 side and on the T1 side, you might take these pair of confirmations as a strong indication that whatever happens in the future, those two things will remain linked. So it's, so to say, a unification that you don't take back even if you move on to the next level of theory. And that would mean that it is, of course, it is based on a theory internal perspective, but it has an aspect that transcends the theory you're working within. So what would you think about that aspect?
Well, I think it makes a difference whether we're thinking about a theory that stays the same or a theory that is growing, where what typically happens is that we keep using the same name for the theory, even though new principles are added, some are modified, and so on, right? Now, let's suppose that in the example you're giving or sketching, it stays the same. Say the two postulates, right? And you get separate confirmation from one, you get separate confirmation from the other. In both cases, the conjunction is also confirmed, right? All that is true regardless of whether they are relevant to each other or not, or everything that I have said, right? But in order for there to be an extra effect of any sort in the change in probability of the theory, there have to be relations inside the prior probability in order for that to happen. Mm-hmm. Otherwise, you'll just have a bit of evidence for life on Mars, a bit of evidence for tortoises eating lettuce, and that's it. So these new, you don't get new probabilistic relations coming into being between them unless there was a possibility for that in the prior.
Mm-hmm. Mm-hmm. I mean, one thought back on that would be, one might say that there are two elements to this. One is the confirmation of the individual theory. The other is establishing that each theory that will follow is also unified. So then you would say maybe it's more difficult to find an entirely different unified theory, because it needs to give you more than to find an entirely different theory for that subsection.
Yeah.
Subsection.
Yes. Well, but you see, if you suppose that you have this kind of improvement that you are referring to, right? The result is a new theory. It's a bigger theory, right? And the confirmation, whatever confirmation you get out of the procedure, will be for the new theory, not for the old one.
Right. Yeah, that's right.
Yeah. Well, I'm glad you're taking this up, because I think this is the main thing really that I wanted to present today. I have another longer example. Could I take a moment to show it? Okay. I have an appendix in my PowerPoint. Okay. So I'm going to give you a theory of extraterrestriality, right? The extraterrestrials are referring to them as aliens. And postulate one is the invisible aliens are here. I mean, here in Stockholm. Okay? They are here. Now, if that's all there is to the theory, we don't have any resources for designing an experiment or a measurement, anything to give it support, right? There are no resources here, right? I mean, I've said the invisible, that's information, but I haven't said anything else about them. Are they tangible? Who knows? Okay. So we have to add to the theory in order to get resources to make a measurement, right? So T2, milk turns sour when they pass by. Well, now we have a connection with phenomena, but because we have no somehow way of telling whether they pass by, it doesn't help sufficiently. We still cannot design an experiment, right? So we add a third one. They're attracted by the smell of cheese. Now we can do it. We have lots of little saucers of cheese and milk, cheese without milk, milk without cheese, right? And we gather data. Now I want you to imagine that the empirical evidence is overwhelming for this theory, that they find this correlation that if there's a little bit of cheese by the milk, it turns sour much more quickly, okay? Overwhelming, okay. Now, do you believe the aliens are here? Okay, now I want to point out that something is confirmed. There was an empirical correlation that was confirmed, right? That's part of the empirical content theory. And the correlation is explained by a deduction from the theory. And the deduction has to use every one of these postulates. There is no redundancy at all, right? The full theory that the aliens are here did receive evidential support. But the statement that the aliens are here, I think probably not, right? It's only a slightly more technical example than the other.
Okay. Any questions on Peter? And then
Yes, thank you. Could you say something about the relation between the concept of a model and the concept of a possible world?
I'm sorry, the relation between
Concept of a model, scientific model, and the concept of a possible world, or classes of models and classes of possible worlds.
there's one word I didn't get. Did you say causal models or just
Concept of.
or the concept of a model?
Yeah.
Okay. Yes, certainly. So yeah, and Nancy Cartwright is always telling me that I'm speaking too much in logical terms. Okay, but this is, I think, in those terms. And I think when Tarski really started logical semantics, it was quite clear what was his beginning. He said to himself, if the statement I'm dealing with is an equation, right? What is important in the world, so to speak, right? In the world of numbers, say, is the set of solutions of the equation, right? And this is what was generalized in the notion of a model in logical terms. A solution of an equation is a model of that equation. And so if you have a lot of equations, there will be solutions of the set. And those solutions will describe the mathematical structures that are the models of the theory. So, for example, if the equation is just x plus y equals 3, right? Then one model is the little sequence of numbers 1, 2. Okay, little mathematical structure 1, 2. Right? So this is how I think about models. Models are essentially the solutions of the set of equations that are presented on the page as the theory. That helps?
Yes, it helps.
Okay, good.
Hans?
I'm going to hold mine.
Okay. James?
I was hoping you could say a little bit more about the Mona Lisa.
About
the Mona Lisa
About the Mona Lisa.
and the role
Yeah.
that it plays here. So,
So
the idea here was that you think of a theory as a category of models, possibly, and we think about the relationship between the theory and the data models as isomorphic embedding. And then the worry would be is that that's a little bit like describing the Mona Lisa as wood with oil pigment. So then you want to say, well, the Mona Lisa is depicting a woman with an enigmatic smile.
Yeah.
So what's the analog of depicting a woman with an enigmatic smile as it applies within constructive empiricism?
Yeah. Well, today when we're talking about the measurement outcome, you have to realize that in practical terms, it'd probably be the output from a computer of a series of a sequence of numbers, something like that, right? So as I say, here's the measurement outcome. I'm trying to get a grasp of the phenomenon, so I made measurements on it, and here's the measurement outcome. And you say, that's just a sequence of numbers. A sequence of numbers. I say, yeah, it's a sequence of numbers, sure. But it is in fact a representation of this phenomenon. Right?
And can you say more about what you mean by that?
Well, you see, in the case of the Mona Lisa, I mean, if you already have to have concepts like, the concept of woman, concept of a smile, and so forth, right? And for instance, I know from experience that some dogs can see pictures as pictures of something, and others cannot. Okay, well, you have to be able to see the picture as a picture of something. You have to have that, right, in order to see that. In the case of the sequence of numbers, if you understand the measurement procedure and how it was designed, and you're sufficiently immersed in the theory by which this was done, then you will look at that sequence of numbers and say, that's what the phenomenon is like. See? So it takes that. I mean, nothing has meaning by itself, right? I mean, Putnam liked to have these examples where on some very distant planet in some distant galaxy long, long ago and far, far away, right? An ant is walking in the sand, and it traces something that, to me, immediately would say Coca-Cola. Well, did the ant write Coca-Cola? No. No. Right. I mean, the inscription doesn't have any meaning, there. I mean, in that situation, right? Yeah.
Any further questions? Yes, Sebastian.
I'm wondering about the procedure of concordance that you brought up.
Yes.
Because if my theory in the first instance determines the value of, say, mass, and then in a second instance also determines the value of mass, and it has to be the same.
Yeah.
Couldn't I just flip it around and say, well, my theory just predicts something, namely that the first value is the same, sort of the data that led to the first have to be value of mass, have to be such that the next set of data have to be the same. And so
that's a prediction. Yes.
But that sounds, exactly. That sounds to me like standard hypothetical deductive confirmation of a theory then, and not particularly subtle new kind of support or so.
Well, it is certainly true that the theory predicts about itself that it is right. Okay, so it predicts that if the way in which the quantity is measured is thus or so, the quantity, right, is measured. So then, when the procedure is applied, and each time you will get the same answer. But it is, okay, you see, what I call empirical grounding, there's a great deal you can do by designing your theory correctly. And perhaps you will need to add more hypotheses into the theory, like for instance, with the development of atomic theory in the 19th century. First of all, Dalton, and there were quantities that could not be measured. And so then Avogadro says, oh, I add this, and so on and so forth, right? Then you could do it. There's a great deal that you can do in designing the theory so as to get toward empirical grounding. But there's one thing that you cannot do, and that is for nature to comply. Right? And so you don't get any experimental support if nature doesn't comply. So you may already have a theory which, according to itself, right, has every quantity measurable from direct measurement via the equations. Sure, that's how it's set up. But then it may not be a true theory. It may not be an empirically adequate theory. Okay? So the concordance is say, okay, now we come to the question whether the theory is empirically adequate or not. And that's where the bite is.
Thank you.
Okay, thank you. Let's thank Bastiaan for...
All right, welcome back. It is my great pleasure to introduce Kyle Stanford, who's going to teach us more about turtles.
Thank you very much, and yes, thanks to the academies and our hosts for making this event happen and this symposium part of the events. This is a great opportunity. In fact, I should say, although Bas van Fraassen and I have very rarely even been in the same room together, it would be nearly impossible to exaggerate the impact that he has had on not just my education, my academic career, but the course of my life. The first set of courses I ever took in college I encountered some of the central ideas expressed in the scientific image, and I've just never recovered from the experience. The excitement of working through, trying to engage with those challenging ideas had everything to do with my subsequent decisions to major in philosophy, to pursue the philosophy of science, and to pursue a career in professional academics. The scientific image not only woke me from my dogmatic slumbers, but also sparked real intellectual joy in me as an undergraduate student that set the course for the rest of my life. And I am absolutely delighted to have the opportunity to thank Bas van Fraassen for having influenced my life so profoundly, simply by writing what has turned out to be one of the few truly indispensable books in the philosophy of science. So thank you. Okay, but we're here today because something quite remarkable has happened in the reception and the engagement with this work in the profession at large. Because the ideas in the scientific image are too important to ignore in a philosophy of science course, but also too subtle for students to easily comprehend, philosophers of science have invented a character who fits much more neatly and simply into the dialectic of the scientific realism debate than the actual Bas van Fraassen does. Okay? That character we're going to call Van Fraassen of legend, or for short, we will call him the Waffle. Right? Now, students grow up and then they go get jobs. And so perhaps it's not surprising that now this pedagogically useful misreading of Van Fraassen and the scientific image is now the most widespread interpretation of the book, held by many, if not most, professional philosophers, including some prominent philosophers of science. Today, I'm ultimately going to suggest that we should understand the scientific image itself as an attempt to interpret the practice of science in a distinctive and revealing way. But I'm going to start making the case for that claim by identifying some important ways in which influential alternative interpretations of the scientific image have stumbled. And our very first step is going to be to see why the Waffle is a profound mistake, despite its persistent popularity, even among some experts in the field. Okay, so the Waffle's deeply troubled by a problem known as the underdetermination of theories by evidence. Underdetermination obtains when the evidence we have simply doesn't discriminate between two competing theories or favor one of them over the other. Familiar versions of the general problem can be found in the famous methodological maxim that correlation does not imply causation. A correlation between A's and B's can be generated by a number of different causal structures. And so identifying that correlation simply underdetermines what we should believe about the causal structure that produced it. Another famous example, right? For fitting curves to data points, we can always find an infinite number of functions that will fit any finite set of data points. Right? If you add more data, you'll rule out functions, but you'll always leave an infinite number left. But the Waffle thinks that underdetermination runs rampant in science because many, if not most, of even our best scientific theories have empirical equivalence, right? Which is to say, competitors to them that make all and only the same observable predictions, and which therefore cannot be better or worse supported by any empirical evidence at all. Waffle illustrates this worry using the now famous example of Tn0, which represents Newtonian mechanics, including Newton's own claim that the universe is at absolute rest. Right? We can generate as many empirical equivalents as we like to Tn0 by replacing 0 with any constant absolute velocity and direction for the universe as a whole. Take the universe as a whole, put it in motion. From inside the universe, observable phenomena will all be exactly the same. As Newton himself recognized, right? Each of the TNV will have exactly the same observational implications or consequences as Tn0 does. So the empirical evidence doesn't justify believing in Tn0 or any particular TNV, for the evidence we have would be just the same no matter which of these alternatives obtained. Of course, we might rightly say that Tn0 is the simplest option, or has some other pragmatic advantage over other alternatives. But we think of virtues like simplicity or scope or fecundity as pragmatic virtues precisely because we don't think that they are evidential. That is to say, possessing virtues that, like simplicity, scope, or fecundity, makes theories more useful to us, but we don't think that being simpler or more fecund makes a theory more likely to be true. Given that the empirical evidence we have doesn't discriminate between Tn0 and the various Tnv, Wafel insists that we have no evidential grounds for believing in one of these possibilities rather than any of the others. Okay, so that's the problem. Wafel's constructive empiricist prescription is to remain agnostic about which, if any, of the various Tnv is true, and to instead believe only that they're all empirically adequate. That is, their claims about observable matters of fact are true. Of course, those are just the claims that Tn0 and all of the Tnvs will share. Those are the claims that will be identical. All right? And quite generally, Wafel thinks that the ease with which we can generate empirical equivalents of this kind suggests that they exist for many, if not most or all, of our best scientific theories. And so we should withhold belief in the truth of those theories and instead believe only in their empirical adequacy. That is, we should believe that all and only the claims they make about observables are true because those are the very claims that will be shared in common by a theory and any empirical equivalence that it might have. For the Wafel, constructive empiricism successfully evades the threat posed by rampant underdetermination of theory by evidence by restricting our beliefs to the empirical adequacy rather than the truth of our best scientific theories. Now, if this were indeed von Fraassen's position, then his critics would be right to suggest that it leaves his case for constructive empiricism in a precarious position. For the constructive empiricist accepts the total empirical adequacy of our best theories, including the truth of what they say about all observables, past, present, and future. But of course, the empirical evidence might just as easily leave us underdetermined between theoretical alternatives that are not empirical equivalents, but nonetheless agree about past and present observable matters of fact, while diverging in their implications concerning future observables. Like that. Same thing with presently unobserved observables. So the specter of rampant underdetermination seems to give us equally good reasons to withhold beliefs from claims about future observables or presently unobserved observables as it does to withhold belief about unobservables simpliciter. As Philip Kitcher presses this challenge, a misguided challenge, I'm stressing, right? We're still talking about the Wafel here. As Philip Kitcher presses this misguided challenge, he says, if von Fraassen's maxim is be agnostic wherever you might go wrong, then the agnosticism he recommends is far more sweeping than he suggests. Okay. But in fact, this prominent criticism fundamentally misconceives the actual motivations for constructive empiricism. Although von Fraassen certainly appeals to underdetermination and the possibility of empirical equivalence to motivate our epistemic caution, he does not recommend believing only a theory's claims about observables because he thinks observability marks the spot where the threat of underdetermination runs out. That's not the view. Empirical adequacy is recommended to us not as a proof or panacea against underdetermination, but instead as the most epistemically modest set of beliefs that nonetheless allows us to take full practical advantage of the predictive and other powers of our best scientific theories. That is the motivation for drawing the line at empirical adequacy. If we believe anything less than a theory's full range of claims about observables, we'll be losing at least some of the predictive or other practical power that the theory has. But if we believe any of its claims that go beyond observables, we will be joining the scientific realist in her empty strutting and posturing and display of courage not under fire in embracing additional beliefs which will ex-hypothesize never brave a more severe test than empirical adequacy itself. Right? That's what uniquely picks out empirical adequacy as the spot, right, for constructive empiricism. To take full advantage of our best scientific theories, the constructive empiricist tells us we need believe in no more than those theories' empirical adequacy, but also no less than their empirical adequacy. In thus committing herself to the full empirical adequacy of our best scientific theories, the constructive empiricist is certainly taking on some epistemic risks and exposing herself to some varieties of underdetermination. But as von Fraassen says, famously, it's not an epistemological principle that one might as well hang for a sheep as for a lamb. Rather, the constructive empiricist seeks to limit her epistemic risks by restricting her beliefs to just those actually needed to secure the practical benefits of scientific theorizing. Her claim is that we gain no additional benefits from embracing beliefs that go beyond observable matters of fact, so we should decline to join scientific realist in her empty strutting and posturing. All right. So this recognition, I think, demolishes the Waffle conception of constructive empiricism as seeking to vanquish underdetermination by restricting our beliefs to unobservables. That's not what's happening. But this recognition is perfectly consistent with an influential alternative interpretation of constructive empiricism, famously offered by Gideon Rosen. Rosen's alternative interpretation begins by considering von Fraassen's infamously idiosyncratic further claim that the realism debate itself concerns the aims of science, rather than its accomplishments. Okay. On the realist view, von Fraassen tells us, science aims to give us in its theories a literally true story of what the world is like, and acceptance of a scientific theory involves the belief that it is true, while constructive empiricism holds instead that science aims to give us theories that are empirically adequate, and acceptance of a theory involves as belief only that it is empirically adequate. This is the difference that von Fraassen suggests is at the heart of the scientific realism debate. Now, many philosophers have been deeply puzzled by these claims about the aims of science, thinking that they must just be a colorful or creative way to talk about what it's realistic to expect scientific theories to be able to accomplish. Rosen rightly rejects that view. Right? But he remains puzzled about these claims, what these claims amount to, and why von Fraassen insists on them. Von Fraassen is quite clear that he does not mean to suggest that the pursuit of empirically adequate theories is the aim of all or most individual scientists. That's a reading that Rosen rightly rejects as turning the scientific image into a work of inept sociology. Right? He's right about that. But at the same time, he's equally clear that he's not arguing that scientists instead should adopt the constructive empiricist's aim, even if they presently don't. In fact, von Fraassen explicitly distances the constructive empiricist's perplexing claims about the aims of science from any view about what the aims of individual scientists are or should be, with an analogy to chess, in which he points out that the aim of the game itself is checkmate, even if individual players are instead playing for fame, gold, or glory. Rosen nonetheless insists that the manifest gap between the constructive empiricist commitments and the aims of most individual scientists entails that constructive empiricism must be false if taken literally. Okay? He goes on to suggest that the view is instead best seen as a fiction about science. Fiction about science. Put forward not as true, but rather as adequate to the phenomena of scientific activity. On this fictionalist reading, von Fraassen is not even trying to describe science as we actually find it, but instead he's suggesting that science proceeds as if scientists had the intentions he describes. Rosen suggests that von Fraassen's fictionalism about science closely parallels constructive empiricism's own view of scientific theories. That's what he says. Just as science is portrayed as an as-if story about nature, so the author's own philosophical remarks about science are to be taken as fictional assertions, expressing a commitment to this theory as an adequate as-if story about the intentional features of science. That is, Rosen suggests that constructive empiricism seeks to characterize science in the same way that constructive empiricism itself holds scientific theories to be characterizing nature. We expect things to proceed in nature as if those theories were true, and science proceeds in its activities as if scientists were constructive empiricists, but these are nonetheless merely useful fictions about nature and science, respectively. Having proposed this fictionalist reading of constructive empiricism, however, Rosen immediately runs into the natural problem. He suggests that von Fraassen has failed to provide any reason to adopt or even care about his fiction that should appeal to anyone who does not already happen to share von Fraassen's own foundational commitments to both the rationality of scientific practice and a broad form of empiricism, insisting that experience is our only legitimate source of knowledge about the world. It started to melt and I took my jacket off, so I'm going to say that again, because that's what you were watching me do instead of listening. Excuse me. All right. Right, here's the thing. Okay, so the fictionalist reading, Rosen says that shouldn't appeal to anybody who doesn't already share two things. Von Fraassen happens to be committed to the rationality of saving the rationality of scientific practice for some reason. He happens to be committed to empiricism in the broad sense that recognizes experience as our only legitimate source of knowledge about the world. And constructive empiricism has no attractions or interest for anybody who doesn't happen to share those two commitments. Right? So he says, why should anyone care whether constructive empiricism is adequate to a certain restricted range of phenomena? Why should von Fraassen be so concerned to argue that scientists sometimes act as if they were concerned only to produce empirically adequate theories, and as if acceptance did not involve belief? What hinges on this particular philosophical as-if story? The most von Fraassen can hope to show, Rosen tells us, the most von Fraassen can hope to show is that constructive empiricism is the most stringent form of a broadly empiricist commitment to science, which at the same time renders the phenomena of scientific activity fully intelligible and ratifiable. Although von Fraassen points out what he takes to be attractions of the view, Rosen thinks nothing he says would or should encourage anyone who's not already and independently committed both to the rationality of science and to empiricism in the broad sense to become a constructive empiricist. Now, this fictionalist reading might seem supported by von Fraassen's equally famous commitment to epistemic voluntarism. He analogizes this voluntarism to what he calls the English conception of law, in which everything not explicitly forbidden is permitted, in contrast to the Prussian conception of law, in which everything that is not explicitly permitted is forbidden. All right? In epistemology, such English voluntarism holds that whatever is not rationally prohibited in the way of belief is permissible. And von Fraassen consistently seeks to establish simply that constructive empiricism is among the rationally permissible or rationally unimpeachable options for interpreting science. He explicitly denies that the considerations he advances establish that we must reject scientific realism or we must embrace constructive empiricism on pain of irrationality. Right? Never. This gentle modesty about the appeal of the position, or its rational non-obligatoriness, makes it look even more as if von Fraassen really might just be treading a very narrow path and encouraging those of us who happen to share his own empiricist and scientific prejudices to join him on it, while the rest of us safely ignore the whole expedition. For the rest of us, who cares if science can be described in an obviously false way? that nonetheless rationalizes many of its activities and practices. Okay, although it captures more of actual constructive empiricism than the Waffle did, Rosen's fictionalist reading must also be rejected as a fundamental mistake. What Rosen, along with many other critics, has missed is that far from offering an obvious fiction about science with which he and his fellow empiricist science fetishists can comfort themselves through their long and lonely dark nights of the soul, no. Von Fraassen is instead proposing a distinctive interpretation of actual scientific practice as we already find it, whose virtues should appeal to us all, even if they do indeed fall short of rationally obligating us to embrace it. Contra Rosen, constructive empiricism is intended for all of us, not just the obsessively cautious science worshippers in our midst. I'm going to start making the case for the claim I just made and the interpretation I'm suggesting by borrowing some ideas about interpretation from the legal philosophy of Ronald Dworkin, who himself relies on the earlier work of Stanley Cavell. Dworkin begins by contrasting what he calls constructive interpretation with a much more familiar conversational interpretation, in which we seek to recover the actual intention or mental state of some speaker who has produced an utterance. So if you say, would you like to go to the movies this weekend, or are you planning to pay for that, my goal in interpreting you will be to identify the mental state that actually led you to produce that utterance. And the right interpretation of the utterance will be the one that correctly reconstructs your mental state. That's how conversational interpretation works. But Dworkin argues that such conversational interpretation is the right thing for some things. It's the right way to approach some things. But he thinks it's not the best way to approach the interpretation of phenomena like works of art, or social practices, or ultimately laws, which are better understood instead as targets of what he calls constructive interpretation. Okay? Don't get lost. There's constructive empiricism and constructive interpretation, and the two constructives don't have anything to do with each other. Okay? So I'll try to remember to call constructive empiricism CE to help with that. Okay, so how does it work? Well, in a constructive interpretation, the interpreter's objective is not to recover the actual intention or mental state of any particular speaker or social actor, but instead to find the interpretation of the work of art or social practice that best fits the object of interpretation itself, while simultaneously seeking to make it, in Dworkin's oft-repeated phrase, the best it can be. That is, constructive interpretations seek to simultaneously maximize two independent desiderata, that Dworkin calls fit and acceptability. A constructive interpretation is better than its competitors insofar as it better rationalizes or motivates more elements of the work of art or social practice as a whole, but also insofar as the aim, point, purpose, or value that it ascribes to the work of art or social practice renders it more independently appealing, interesting, useful, significant, mind-blowing, or just plain cool. By whose lights? By the lights of the interpreter and any audience she hopes to convince to share her interpretation. Okay. For the constructive interpreter, the right reading of a man called Ove, or Pippi Longstocking, is simply that which best manages to maximize both fit to the object of interpretation and independent attractiveness to the greatest possible degree. Whether or not such constructive interpretation is the right option for interpreting works of art or the law, it's Dworkin's suggestion that it's the right approach to interpreting social practices, in our case scientific practice, that puts us in a position to make much better sense of von Fraassen's project in the scientific image, and I will ultimately suggest considerably more in the philosophy of science. For one thing, such constructive interpretation offers a natural way to understand von Fraassen's claim that the scientific realism debate ultimately concerns the aims of scientific activity. This is precisely the claim about any practice with which its constructive interpreter is most centrally concerned. What aim, rationale, point, purpose, or value is she proposing for the activity or the practice that she seeks to interpret? But neither the constructive interpreter nor the constructive empiricist is making a claim about what most people involved in the practice take its aim to be, nor with what aim they should adopt for the practice instead. Nor, contra Rosen, is she simply proposing comforting fictions about the practice. She's instead making a claim about what the aim of the practice itself already is on the best fitting and most attractive interpretation of it that we can find. So this suggestion should make clear why constructive empiricism is neither seeking to describe nor even particularly concerned with what most individual scientists take the aim of science to be. One of the grounds on which Dworkin argues that interpreters must construct social practices in the course of interpreting them is that in practices like funerals or voting or football tournaments, there simply is no canonical participant or group of participants whose individual opinions about the point of the enterprise could automatically or dispositively settle the issue in the way that the actual intentions of a speaker do when we're doing conversational interpretation, right? No individual's conception of the aim of the practice has that kind of authority. Even the president can be wrong about what the point of voting is. Here is the one-step proof. Mine is wrong about what the point of voting is. Any individual's conception of a practice in which she herself participates simply represents a candidate constructive interpretation of that practice like any other. And we're more likely to think it is the right one as it better maximizes both fit and acceptability, making the practice the best it can be while simultaneously motivating or rationalizing as much of that practice as possible. Likewise, in the scientific case, there's no canonical person or group or institution whose individual views on the aim of science could even plausibly serve to settle this question dispositively or authoritatively. Even Einstein or Darwin or the head of the NSF could be wrong about what the point of science is or what its aim is. Although scientists speak with especially detailed knowledge of their own practices, their own views about the aim, point, purpose, or goal of science itself do not automatically have any special standing or claim to authority. When scientists express such views, they themselves are acting as constructive interpreters of science. They propose views of what science itself has been aiming to do all along, and how to best extend that practice going forward in light of that aim. Such proposals must be evaluated in precisely the same ways as those offered by philosophers of science or anybody else, just as empirical hypotheses proposed by philosophers should be evaluated in just the same way as scientists' own empirical hypotheses. All right, now recall Rosen's claim that von Fraassen has simply created a fiction about science that holds no interest or attractions for anyone who does not already share his own prior commitments to both empiricism broadly and the rationality of scientific practice. We can dispense with the suggestion that von Fraassen is simply preaching to the choir if we understand his sermon instead as an attempt to constructively interpret science as a social practice. On this view, it's the need to generate a convincing or faithful interpretation of the practice, that is to say, to maximize fit, that motivates the constructive empiricist to try to rationalize as much of that practice as possible. It's not a prior commitment, an undefended commitment to the rationality of science itself. Similarly, we need not follow Rosen in seeing the further virtues that von Fraassen claims for constructive empiricism simply as attempts to make its attractions vivid for those who already happen to share his own foundational commitments, but instead as virtues that should appeal to us all. Von Fraassen's arguing for what Dworkin calls acceptability, which is to say the independent appeal of the interpretation he offers when he points out things like constructive empiricism exposes us to far fewer risks, epistemic risks, than realism does, but nonetheless lets us use science to do absolutely everything realists can do with it. When he points out that constructive empiricism eliminates the need to see scientists as embracing beliefs about nature on the strength of comparative virtues that are pragmatic rather than evidential in character. Or Again, he disdains the scientific realists, the constructive empiricism disdains the scientific realists' empty strutting and posturing and display of courage not under fire and embracing additional beliefs, which will ex-hypothesize and ever brave a more severe test. After all, one need not be even a broad empiricist to want to avoid useless or pointless or unproductive epistemic risks, or to want to limit the influence of non-evidential considerations in determining our beliefs, or to find empty strutting and posturing and grandiose expressions of courage not under fire distasteful. Though von Fraassen pretty clearly thinks that constructive empiricism more effectively rationalizes more of the practice of science than the realist alternative does, we can nonetheless see his claim that constructive empiricism makes better sense of science and of scientific activity than realism does, as asserting the superiority of constructive empiricism to scientific realism on grounds of independent acceptability as well as fit. That is, we should see constructive empiricism as offering what von Fraassen takes to be the most appealing conception of the point, purpose, value, or aim of the social practice of science, acceptability, that also best explains, rationalizes, and defends as much of the actual activity of science as possible. Fit. In this, he offers a characterization of the aim of science itself, as opposed to the aims of any or all of its individual practitioners who may play for fame, gold, or glory. And that proposal is simultaneously descriptive and normative, right, in precisely the way that constructive interpretations invariably seek to be. There's no better answer to the question of whether a constructive interpreter is trying to describe or advocate or reform the aim of the practice as it already exists. The constructive interpreter ascribes an aim, purpose, or point to the practice in the course of trying to construct what the existing practice itself already is. And so she's either doing all three of those things, right, describing, advocating, and suggesting reform, or none of them at the same time. There's no better answer. Now, some of you might, I think I've seen some eyes starting, some of you might be tempted to scan Boss's face for little clues about whether I've got him right or not. But if you're tempted to do that, you've missed a little part of what I'm doing here, okay? I'm offering a constructive interpretation of the scientific image. And to succeed at that, I no need to care any more about the author's intentions than von Fraassen has to care about how many scientists have signed up to be constructive empiricists. Right? His claim is that he's offering at least an attractive and perhaps even the very best constructive interpretation of science, whether any scientists know or care about it. And that's what I'm saying about the scientific image too. I'm suggesting that the best way to understand this important and deservedly influential book is to see it as having the aim of providing a constructive interpretation of science itself. And I think that whether von Fraassen himself agrees with me or not. Okay, we're going to skip over some things that I might disagree with in Boss's constructive interpretation of science in order to focus on a much more important point. What I want to do now is go on to suggest that the tools of constructive interpretation might play an important role in our understanding not just of science itself, but also of at least some important parts of what we ourselves are up to in the philosophy of science more generally. That is, I want to suggest that the form of interpretation that the scientific image embodies itself has productive applications elsewhere in the philosophy of science. Let me begin with a long-standing tension in the self-conception of philosophers of science concerning whether ours is fundamentally a prescriptive or a descriptive enterprise. Many philosophers of science, I suspect, find themselves in an uneasy tension between competing impulses on this question, thinking that the job of the philosophy of science is to understand and describe the workings of science as we actually find it, but also that there's an important normative dimension, a prescriptive dimension to this enterprise, and that it's sometimes appropriate for philosophers of science to draw conclusions from their own work concerning how scientific inquiry should be conducted in general, or in should proceed in some particular case. I think constructive interpretation allows us to reconcile those competing impulses in an attractive way. So both impulses have, I think, been deservedly influential across the history of the philosophy of science itself. But each has also sometimes been too influential. When the prescriptive impulse has exerted an outsized influence, it has produced a variety of philosophy of science that we might caricature as the epistemic police. The epistemic police suppose that the role of philosophers is to justify and protect the epistemic authority of science while correcting and or improving the activity of scientists by telling them what the demands of rationality are, or what the demands of genuinely scientific theorizing are, and when or how those demands have or have not been successfully met. That caricature captures some of the flavor of Karl Popper's falsificationism, Lakatos's methodology of scientific research programs, as well as some improvident arguments in support of contemporary formal theories of confirmation. And of course, some logical positivist and logical empiricist thinkers were sufficiently confident in this normative role to be willing to replace the actual history of science with rational reconstructions of that history in order to more clearly draw the appropriate normative morals from it. For any number of very good reasons, more recent philosophy of science has tended to take a far more deferential attitude toward the details of actual scientific practice and the historical record of how scientific inquiry itself has actually proceeded. Most contemporary philosophers of science simply do not take themselves to be in the business of telling scientists how to do science. Right? Better or worse. We were, but we're not. This otherwise welcome humility, however, has sometimes threatened to generate an almost purely descriptive form of inquiry, whose caricature might be called the anthropology of science. Anthropologists of science reject the presumptuous penchant of the epistemic police for lecturing scientists concerning how to conform their practices more closely to the demands of rationality or the requirements of genuinely scientific inquiry, and seek instead simply to describe and understand the scientific enterprise as we actually find it, and hopefully to draw instructive morals from the resulting more detailed and more accurate conception of that enterprise or some part of it regarding how science is able to do what it does. Much of the work of the anthropologists of science consists of careful field reports concerning the actual theoretical commitments, practices, views, or thinking of various groups of scientists, often preceded or followed by vague and hopeful gestures toward traditional philosophical questions about the nature of scientific inquiry that might thereby be illuminated. Now, I think constructive interpretation offers us a way to recognize the attractions of the epistemic police and the anthropologists of science, while allowing us to dispense with them both. We philosophers of science can reconcile our competing prescriptive and descriptive impulses in an attractive way, I suggest, by seeing what we ourselves are doing, at least some of the time, as offering candidate constructive interpretations of all or part of the social practice of science itself. Here we go. So Dworkin emphasizes that such constructive interpretations invariably begin with some pre-interpretive identification of the objects of interpretation. The poem on the page, the play on the stage, the text of the Constitution, or the social practice, in this case scientific practice, as we find it. And as we saw, a good constructive interpretation of science will seek to maximize fit to the objects of interpretation. Thank you. We're going to move a little faster. We'll seek to maximize fit to the object of interpretation, trying to motivate, explain, rationalize as much of it as possible. But constructive interpretations also retain the freedom to ultimately exclude some part of the pre-interpretively identified object of interpretation as mistakes, because fit is not all that matters. At some cost to the fit of their interpretations to the practice that they're interpreting, constructive interpreters of science are free to reject parts or aspects of science as we find it as inconsistent with the best aim, purpose, point we could ascribe to the rest of that practice as a whole. That is, with a constructive, on this view, rejecting a given part or aspect of scientific practice as mistaken, or even just suboptimal, is similar to rejecting a part of a play or a book or a line in a song as contributing nothing towards, or even detracting from, detracting from what is otherwise the most attractive constructive interpretation of the play or song's point, purpose, aim, or value, and therefore not actually being part of the play or book or song as it is best interpreted in the first place. In extreme cases, a sufficiently attractive constructive interpretation may lead us to reject a substantial part of the pre-interpretively identified object of interpretation, as when many critics reject the disastrous final third or so of the Adventures of Huckleberry Finn as inconsistent with the best constructive interpretation of the book as a whole, even at considerable cost to the fit of that constructive interpretation with the full text of the published novel itself. For these interpreters, the final chapters of the final third of the novel are a mistake, and we should throw them out, in just the same way that even widespread scientific practices of fraud or dogmatic adherence to a theory or poor statistical methodology can be regarded as normatively mistaken. Although these are familiar features of the practice of science as we pre-interpretively identify it, they are nonetheless inconsistent with what we see as the independently most attractive conception of the point, purpose, aim, value, or significance of that practice. This view of the matter allows us to understand the appeal of the epistemic police and the anthropologists of science while dispensing with them both. It sees each of these traditions as focused excessively on just one of the evaluative dimensions of constructive interpretation, acceptability and fit, respectively, and insufficiently attentive to the other. Accordingly, it rationalizes the broad lines of criticism that rightly make each of these caricatures unappealing. The complaint that the epistemic police are seeking to characterize a philosophical fantasy rather than the actual scientific enterprise, and the complaint that the anthropologists of science settle too quickly for mere description, prematurely abandon any substantive normative appraisal of whether and how features or elements of scientific enterprise, as we pre-interpretively identify it, should be revised, rejected, resisted, or reformed as that practice is extended into the future. Beyond respecting these prescriptive and descriptive impulses, I suggest that seeing much of the philosophy of science as engaged in attempts to constructively interpret science or parts of science promises to rationalize much of the rest of what philosophers of science themselves do and say, at least a lot of the time, including their efforts to develop and defend so-called philosophical theories of explanation, confirmation, and the like. Bayesian confirmation theory, for example, does not seem like a promising description of the process by which actual scientists make all things considered confirmational judgments, nor do most Bayesians seem to be suggesting that we simply ignore scientists' own confirmational judgments and adopt the Bayesian apparatus as a way of making such judgments instead. Bayesians are best seen, I think, as offering constructive interpretations that seek to rationalize as much as possible of existing scientific judgments of comparative confirmation and evidential virtues and so on, while also offering the most independently attractive conception of that practice, in part for familiar reasons concerning Dutch books and the like. If this suggestion is right, then it's a mistake for philosophers of science to think of themselves, as they often do, as engaged in the sort of hypothesis testing with which they see scientists and scientific inquiry as primarily concerned, using details of the history or practice of science as the data for which any philosophical hypothesis about the nature of science or some part of science is responsible. But philosophy of science is not science, nor are its central activities best assimilated to hypothesis testing. Perhaps the most important difference is that scientists are not free to normatively evaluate and reject their data in the same way that philosophers of science normatively evaluate the practices of science itself. That is, scientists can and do evaluate and reject particular data as suspect or unreliable, but they're not free to reject what they take to be genuine empirical results as normatively inappropriate or mistakes simply because they conflict with what is otherwise the most exciting, impressive, interesting, mind-blowing way to think about nature, right? That would account for the rest of the data. It's not a ground you can have for rejecting your data. By contrast, philosophers of science are free to propose constructive interpretations of science as we pre-interpretively find it that reject even widespread aspects or instances of that practice as normatively inappropriate or misguided or inconsistent with the best conception of the point, purpose, goal, or aim of scientific practice as a whole. And in fact, I've suggested that part of doing so is part of the very point of conducting philosophy of science itself. Of course, the suggestion that philosophy of science is, at least often, in the business of constructively interpreting science, is neither purely a description of everything that philosophers of science presently do, still less what they already think of themselves as doing, nor is it purely a recommendation regarding what I think they ought to be doing instead, because philosophy of science is itself a social practice, and therefore stands in need of constructive interpretation, which is to say, a simultaneously descriptive and prescriptive conception of its aim, point, purpose, value, goal, or significance, and how we might accordingly continue that collective practice into the future. By its own lights, the constructive interpretation of the philosophy of science that I have offered will have to compete with others on grounds of fit and acceptability. And I suggest that this interpretation not only best fits or rationalizes much of what philosophers of science say and do, but also offers an independently attractive conception of much of what we have been up to all along. So, von Fraassen's pioneering work in the philosophy of science has given us new interpretive tools with which to conduct our work. But when it comes to interpreting ourselves, it is turtles all the way down. Thank you.
We have time for a couple of questions. Over there.
Thanks. That was great, very enlightening and entertaining. I want to ask you maybe to say a little bit, in light of Bas telling us that he started off really interested in Reichenbach, maybe just to draw out how you see the difference between this and rational reconstruction. Because you kind of hinted at it, I guess, in a couple of places that, for instance, when you had like the positivists on the one side, that's overly normative. But you do keep bringing back the kind of important role of rationalizing constructive interpretation.
Yeah,
so
good.
Could you maybe draw it a bit more?
Yeah. So if we think back about the logical empiricists and the motivations behind rational reconstructions of history, right? The idea was, look, they were untroubled at all by the normative character of what they were doing, right? And so the point of looking at the history of science was really to just bring out those normative morals. And so we didn't even actually care that much about how science actually went, right? We knew what our normative morals we wanted to draw, and so we told stories about scientific episodes in order to present those morals, right? This is, again, what it is like to be excessively fixated on one dimension of constructive interpretation while ignoring the other, right? Just focused on the prescriptive dimension. Now, the kind of rationalization language that is used in here with constructive interpretation works differently in part because it doesn't start in that same place, right? In a way, right, there isn't an alternative, at least Dworkin argues, right? There isn't an alternative to constructing something like a social practice constructively. And so it's not the case that we already know, right, what the normative point's going to be, and we're just worried about fitting the historical evidence or evidence from the practice of science in order to draw that out, right? It is true that we're engaged in constructive interpretation. We are giving ourselves the right to take particular parts of scientific practice and say, oh no, that's real, that's really part of scientific practice, but it oughtn't be. It shouldn't be understood, right? Fraud is not part of the search for truth. And so an easy but probably misleading way to say it would be it's the holistic process that's involved in constructive interpretation. What's blameworthy, I think, about the rational reconstruction of history is that it treats the data for which or the objective interpretation for which an interpretation is being presented as unimportant from the beginning. It's not an attempt to fit it at all.
Thanks.
Thank you. So I was wondering, when you talked about comparing different constructive interpretation, to what extent you might be relying on the idea that there would be an interpretation independent standard of what counts as fit and what counts as the other one, the acceptability.
Mm-hmm.
So my sort of worry is something along the lines of maybe the realist and the constructive empiricist might just disagree as to what counts as this independent acceptability dimension. And then in which case, under what conditions you would go about determining whether one constructive interpretation trumps another?
Yeah, so good. So it can certainly be the case, and is often the case, that people disagree about what's most attractive or cool or mind-blowing or makes something, an interpretation great, right? Now, of course, this machinery gets set up, and Dworkin is arguing in the context of the law. And so there's a sense in which we have to, a judge making a decision has to decide on a constructive interpretation of the law that they're interpreting, because at the end of the day, we're going to send somebody to jail or we're not, or we're going to find somebody or we're not. And so it's a little easier there to make the case for, look, what could you do except, right, say what you think the best is. In a case like this, it does seem more possible to step back, right, and say, no, well, these are just alternative constructive interpretations. None of them need to be the best. And in fact, one might think, I think one would be me here too, that fits nicely with the epistemic voluntarism, right? That would be one ground for saying it's not rationally obligatory to be a constructive empiricist or a realist, is to say different people can like different things about interpretation, right? And so somebody who wants to speak the language, though, of no, this is the right interpretation of science and these other ones are wrong, what they're implicitly committed to is the objectivity of normatives, of standards by which we evaluate acceptability and explanations, right? And so in a way, the important part is to recognize the detachability of that commitment from the illuminating value of applying the analysis to this particular cases, right? I think you could see, I've talked in terms of the right interpretation of science and less right interpretations of science or something, because in a sense that's the easiest thing to do, right? But you could take either of those views about what competing constructive interpretations are like. On the other hand, the last thing I'll say about this, right, that can sound easier to live with than it is, because, of course, when we try to convince people to share our constructive interpretations of things, part of what we try to convince them of is the values that we're relying on in saying that the interpretation itself is better. And so whenever you have two people sincerely disagreeing about what we should say the aim of science is in this sense that I've perhaps over-explained, whenever we have two people really disagreeing about that, those two people are going to be dissatisfied with just saying, oh, well, we find different things impressive. They're going to regard that as an interpretive disagreement that they need to resolve to walk away satisfied, right? So we can make it a kind of ecumenical attitude look easier to live with than it is. But you're quite right to put your finger on that spot as the thing you're making a commitment on if you want to talk about what the right interpretation of science is, as opposed to just there are alternatives and you can pick the one you like.
For the sake of time, we have to end it here. But
I'm sorry, that's my fault.
Yeah.
Yes.
It's just thrown out. It looks great. I'll stop helping.
Yeah, and I'm very happy to introduce a talk that I can, at least in half, say without accent. Musste das Wissen aufheben von Fraassen on the priority of the manifest image. Thank you, Hans Halvorson, who's giving the talk.
It was very well set up to have a German speaker say that part, so I don't have to say it. Thank you very much. What a privilege to be able to share this ceremony with Bas, a valued colleague and example, and also with those of you, nice to see many friends and familiar figures in the field in the audience here. So as typical with philosophy talks, you know, in 3 minutes I'll be, you know, in the thick weeds and you'll forget. But so let me just start by saying what the overall point is. And actually, this is a very hard overall point for me to say as somebody of Scandinavian origins, as you can tell from my name, is the point is people. And of course, this is like Scandinavians don't like to say this thing, right? Because, you know, we're the types who we show we're friendly by not looking at our own shoes, by looking at the other person's shoes, right? So, but the point is people. And so I think the thing is, also I can say something very honest that's true for many of us, is Bas made philosophy of science cool. And so, and I could go on, I have a similar story to Kyle's, thanking Bas in many ways for my own career. Okay, so I'm also in the position of being a middle-aged philosopher, and that's the time when many people start to ask themselves, what was this all about? And I think to the extent to which you give a great effort, it can be the more discouraging that you might think all of the efforts I put in, what were they for? Were they without purpose? And so there's been a great mission that I think we would look back and say probably would have been better for the world if they hadn't undertaken the mission at all. And so what I want to ask today is, what was Bas's mission? And I actually think this is, you know, I believe very strongly, I'm just the first of what will be a long conversation going on for years and years. Philosophers, great philosophers, provoke discussion among what they were doing and what they accomplished. And so I'm not pretending that I'll be able to give anything like a final answer, but I do want to give a slightly different angle, because I've been thinking about this actually for a long time. And so Bas probably will be to some extent flattered, but also to some extent, as you might say, freaked out by how much other people think about him and what he's doing. So I'm going to do a little bit more of that. So actually, you know, Bas has contributed an enormous amount, so much actually that when I arrived at Princeton University in 2001, and I was a young faculty member, and so I hung around a little bit too much with PhD students. And they said something, they said, oh, you mean the von Fraassen triplets? And I said, what? The von Fraassen triplets? And they said, yes, there's no way there's just one of him, because they produce so much of such different variety that there must be three. So that was a sort of joke the PhD students had. So it's true that actually Bas has produced this incredible amount of different things in philosophy. The architect of constructive empiricism that we just heard about. He's also the architect in the philosophy of quantum mechanics, of the modal interpretation of quantum mechanics. He's in many ways the architect of, and at least the greatest promoter of, the semantic view of theories. Also of voluntarist epistemology, both in philosophy of science, but just in general formal epistemology. The list could go on and on and on. But actually, in some sense, I want us to step up even a level higher from that. Those are particular outputs, but in a sense, I actually think there was an even more important underlying mission. And yes, this is certainly coming from my point of view, my sense of what role we as philosophers of science have actually to play in the world. Because many, you know, there's a lot of bad talking of philosophers of science, insofar as they get talked about at all. And it's also true, as my PhD advisor said once to me in a discouraged moment, he said to me, most of us in this field are refugees from science. And he thought that was both a bad thing and a good thing. The bad side was he thought, well, some of us, you know, we couldn't quite hack it in science. Now, that's, again, a reason why, like, it's incredible to have Bas in the field, because you can't doubt this is not a guy who couldn't hack it in science. He hacked too much, right? He couldn't be held, so to speak, by any particular bit of science. And so what are we actually trying to accomplish here? And I've really come to believe, again, from my personal point of view, but, you know, a world with many different crises, but there's one little crisis that we're particularly well suited to handle, and that is there's this incredible polarization between science and the humanities. And science, as it's gotten more and more specialized, actually in some ways more and more loses its soul. And it's people like Bas who have held it together. And for me, I feel like so it's very strange talking to Bas, because I feel like what an amazing effort. And I think the guy's probably got to be totally exhausted and just depressed, because it's such a huge effort. And he's just got so much joy. And you think, how is that possible? Because it's a huge task. So anyways, I think this is the thing I'm going to emphasize today is actually, in a sense, I think what Bas has done is given a gift to science. Because of course, the greatest commodity science has is human beings, the people who do it. And if it's turned into something that's not actually interesting for human beings, the good, smart human beings won't do it. Okay, so in a way, this is the short story I have to tell you, although we'll get a little bit long in a second. But actually, I think a huge contribution is Bas van Fraassen's humanizing of science. Okay, so there's somebody I'm going to tell you a little bit about later on in this talk, and the reason I know about him actually is because of Bas van Fraassen, but actually I think Bas doesn't know that much about him, so I'm going to sort of tell him a little bit more. So there's a Danish philosopher named Harold Hoefding, and as I'll tell you in a bit, Harold Hoefding helped create the intellectual culture that made Niels Bohr possible. And of course, if you go just a couple hours away from here to Copenhagen, immediately say, okay, that's the most important thing that ever happened, right? So in Copenhagen, I think, right, whatever made Niels Bohr happen, that's the most important thing ever. But he did contribute in a massive way to science. So now to start to use some terms from Wilfrid Sellars, so Bas's teacher that I'm going to talk about quite a bit is, this, I think, was Bas's mission in some sense. Again, I feel justified after Kyle's talk in saying this is Bas's mission, because now I'm doing constructive interpretation. Right. So
it works every time.
Yeah, is creating a space of reasons in which human beings can flourish intellectually, creatively, and scientifically. So here's a quote from one of his great works, The Empirical Stance, at the very end. He says, "I do not think we need new theories in philosophy, but we must change back the way we do philosophy in aid of an authentic, engaged project conscious of its own limits." So here's where I'll go from here. So I'm going to talk first about Wilfrid Sellars and the problematic he set up, which I'm going to characterize drove Bas's vision in philosophy, and then discuss how Bas met that challenge, and then take you on a little short tour of something that I got into because of trying to understand what Bas was doing, and it is my own twist on it, and something hopefully that many of you won't have heard before, that I feel like I was fortunate to uncover, and then finally returning to this funny German phrase, which I'm sure many of you recognize is from the mouth of Immanuel Kant, although of course autobiographical in the mouth of Kant, the ich instead of er, and Kant saying, which I'll say a little bit more about later, this is actually really strange. In English, this is regularly translated as suspend or even limit. And so it's kind of interesting, aufheben in German. Okay, so Sellars, so let's just go straight to Pittsburgh circa 1963. Incredible time and place. The Department of Philosophy there had just really begun because of Adolf Grünbaum. And you can ask Bas for some interesting stories later. I only know them anecdotally, of course. But these three guys were there at the same time. So Adolf Grünbaum, Wilfrid Sellars there, and then somebody who probably you haven't heard of, many of you, but I know now because of Bas, is Joseph Kuckelmans, who's gonna come a little bit in the story later. And so the problematic, so actually right before he came to Pittsburgh, Wilfrid Sellars gave this famous lecture, which then became an article, Philosophy and the Scientific Image of Man. I'll mention more in a minute about, so this article also plays, Pittsburgh became a place that was obsessed with this article for many decades subsequently, and I was fortunate enough in the 1990s to enter into the place where everybody talked about this. So it was like being baptized with the scientific image of man when you arrived at Pittsburgh in the philosophy department. But here's the basic story. Sellars dramatizes this idea that we human beings, there's this sort of tension between the world as we know it pre-scientifically and the world as we get to know it when we get into theoretical science. So here's what he says. He says, the task of the philosopher then is the philosopher is confronted by two conceptions of man and the world, and he cannot shirk the attempt to see how they fall together in one stereoscopic view. So here my diagram, right? The two eyes, the original eye, in some sense, the manifest image. This is just reality as you experience it. And Sellers really lays heavily upon this is the image of where the world is populated with persons, right? So he talks frequently about the discovery of oneself, and then also the discovery that there are others, there are other people in the world. So that's the manifest image. It also gets wrapped up sometimes for Sellers in this whole idea of the space of reasons mimicking the Kantian kingdom of ends. So it's the world in which there's reasons for doing things, worlds in which there are norms, in which there are rights, et cetera, but it's a world that disappears from view when you're doing especially something like fundamental physics. There are no rights of electrons, right? There are no reasons why an electron comes out spin up. Okay, these are parts of the manifest image. Sellers says, a job for us as philosophers is to puzzle this out. You might think in a certain sense, the typical scientist gets to sort of pretend that everything's blue, right? And just sort of live in that world, except of course, the moment they walk out of the lab and someone says, do you want to be paid at the end of the month? And then suddenly they're back in the manifest image temporarily, right? Okay, so now let me just give you an example so Sellers uses the famous Eddington two tables example. So it's a sort of classic, manifest image, scientific image. Here's the podium. If I hadn't had any training in science, if I was just, a child of say 11 years old, and I'd say, here's something solid, it has a certain color. Then later I learned some physics. Imagine you don't learn quantum physics, but you just learn classical physics, and you think, okay, it's actually a bunch of molecules, there are certain forces holding them together, et cetera. So two worlds, you think, oh, how are these related to each other? But here's a more pressing example, which actually, interestingly, it's an interesting time parallel with the Sellers thing. So relativity theory had been, of course, around since the early 1900s, and there was a debate that, of course, happened for the most part in Europe about its significance. As with many things, it sort of got rediscovered in the United States in like the 1960s. So around the same time that Sellers was writing Philosophy and the Scientific Image of Man, Hilary Putnam, another great American philosopher, he said, look, if you believe special relativity, everything you used to think about your relation to time is wrong. You've been living in an illusion. Because actually, in a 3-page, tightly argued analytic argument, I'm going to show you that if you believe the special theory of relativity, then events in the future and the past are just as real as an event now. There's no objective distinction to be drawn. This is just science. In fact, Putnam ends his article, which came out in 1967, but was already a lecture several years before. He says, there are no more philosophical questions to be asked about time. They have been settled. That's the scientific image. And that Putnam, the Putnam of the 1960s, thought the manifest image I of our relationship to time should just be subsequently closed because it was just a blurry, confused view. Fully embrace the scientific image. So that's the tension really felt because, of course, what Putnam probably didn't know at the time, being an American-trained philosopher who never read all the stuff that happened in, say, the 1920s, there, of course, in the early days of reception of relativity theory were people who said, no, it's the opposite. Actually, relativity is like a fictional instrument. The truth is one of actual becoming. So Bergson, right, for example, who said, no, the manifest image rules the scientific image. That I is blurry and confused. So this is an old debate, but of course it comes alive again this time. So that's actually in the back of my head as we go forward here. So here's something I've already said, and I think I've characterized this enough, but just look there what Sellers says about the nature of these images. So he says, I've characterized the manifest image of man in the world as the framework in which man encounters himself, being a person. And I'll just go on from that. So then what comes next is Sellers, in that article, Sellers gives sort of tentative responses. And it is a great article in the sense of many great pieces of philosophy where you get to the very end and you think, I'm not totally sure what just happened. I'm not totally sure what he was recommending. But he does along the way say things like, there's this old view that's like, he doesn't mention Bergson, but this view where actually the manifest image stands. And he calls it, Sellers calls it the perennial philosophy. So the perennial philosophy is the one that says, this is a direct quote from the article, the manifest image is endorsed as real and its outline taken to be the large-scale map of reality in which science brings a needlepoint of detail and an elaborate technique of map reading, but no genuine revision. Okay, so the manifest image is prioritized in the perennial philosophy. And here's what Sellers says, I'm implying that the perennial philosophy is analogous to what one gets when one looks through a stereoscope with one eye dominating. So, of course, Sellers, this is his way of saying, I don't like it. Now you can read, there's many more things he says to indicate he doesn't like it. So what's the contrast? And here you can actually genuinely feel Sellers has this sort of attraction, but a worry. And so Sellers uses Spinoza as his prime example of somebody who decided, in truth, the scientific image is where this is all headed. So here's what Sellers says. He says, I seem therefore to be saying, this is Sellers, I seem to be saying that man is not the sort of thing he conceives himself to be, that his existence is in some measure built around error. So the manifest image, he's in illusion. One thinks, for example, of Spinoza, who contrasted man as he falsely conceives himself to be with man as he discovers himself to be in the scientific enterprise. So this sort of Spinoza idea where it's almost like a story of salvation, right? Where your salvation is to overcome being trapped in the manifest image. It's like, Descartes on steroids, right? Descartes is like, we learn physics, we learn the world is different than it seems. It's like a gift from God. And Spinoza's like, yes, keep going, right? Go all the way to realizing that what really is just the one substance and you're just a mode. That's what science tells you. So give in, become part of that. I'm going to come back to this ambiguity. I got my slides out of order. So of course, this goes on, and my reading, and this is where I'm going to be a little bit liberal with my history of philosophy. I'm not a historian per se. But actually, in many ways, I think a large swath of analytic philosophy from the 1950s, 1960s onward is actually just a footnote to Spinoza. It's basically looking for intellectual salvation through science. So the idea is let the scientific image, this is not a quote from Sellers, this is just me, let the scientific image account for everything, including the describer who produced it. So there's their mission. With many specific implementations, whether it's reduction going all the way back to Carnap and then syntactic view of theories, whether it's a more sophisticated view like supervenience, or now it's gotten really sophisticated in the last 15 years. Now supervenience is outmoded. Right now it's grounding, and there's a massive literature on grounding. The super sophisticated version of everything actually bottoms out in the scientific image. Now, what I want to point out here, and this is going to bring our minds back toward Boss's mission, in all of this stuff, there's not a drop of existentialism. There's not a drop of myself. The self always comes after the system. It's an afterthought. So it's a mission to try to do that, to try to pull that off. Some people think that's an important mission. Some people's lives as philosophers are devoted to trying to carry that out. More power to them. That wasn't Boss's mission. Okay, so just to fill in more, if you think, who's he talking about? Well, I'm talking about everyone. I'm talking about all the who's who in philosophy, so to speak, but all the implementations. So my specialties in physics. The measurement problem in one sense. Now look, I'm not denying there's a real problem in physics, but the anxiety it provokes is an almost spiritual anxiety. among certain philosophers. And if you talk to them, you realize their entire sense of their purpose in life is at stake here, because for them, the purpose is to find how everything sits in the scientific image. And if they don't pull that off, their careers are failures in their minds. Or, in other words, if they don't help the world to see this as a problem, the world is going to be an illusion forever. So the measurement problem in quantum mechanics. Of course, there's this, I'm hailing from, I spend most of my time in central New Jersey, which philosophy is like this. It's very clubby, right? So where you are in the world, things like surround you and you think this is what everybody's talking about. So in central New Jersey, there's this crazy view going around that people call now the mentaculus, which is like a weird reference to some movie. But basically it's like, let's do this massive reductive program where everything bottoms out in the, distribution of primary quantities to space-time points, and then everything else is just, derived from that. So that's, David Albert, Barry Lower, et cetera. Of course, the whole David Lewis program is in a certain sense, David Lewis is just like a very good Spinoza, right? It's like just a very, very technically adept Spinoza. And even, so Hartree Field, that whole science without numbers program, what is that really all about? Well, numbers are bad, right? Because they're not really part of the scientific image. So you better get going on a hard technical project to try to get them out. Now, the point I want to make here, so that I'm not bad-mouthing these, because we all have to make ventures in life, right? We all have to choose what projects to invest our time in. But I'm just pointing out that these projects, and sometimes a project's yield is good whether or not the motivation was good. But these projects were driven, in some sense, by this idea that we have to actually get everything reduced to scientific image. So they're part of the response to Sellers, where the idea is really ultimately the manifest image, we're gonna see through it to the real thing behind. Okay, so let me go back though, because Sellers, if you read that article closely, you can see Sellers is actually himself a little bit on the fence about these things, although the standard story is Sellers basically at the end of the day says, yeah, scientific image wins. It has priority. Now the point I'm making now, the sort of hermeneutic point, is when Sellers says priority, you have to scratch your head and say, what does he really mean by priority? Because here's what he actually says. He says, the very fact that I use the analogy of stereoscopic vision implies that as I see it, the manifest image is not overwhelmed. Okay, not overwhelmed. I'm sorry, I didn't mean to go forward. Oops. Okay, and then he also says, though, if you think, okay, so Sellers actually wants to have both. He says the first, this is like the first possible response to this dilemma, this problem of the manifest and scientific image. He says the first, which like a child says, both, can I have both? Can I have both the cake and the ice cream? Can I have both scientific and manifest? It's ruled out by a principle which I am not defending in this chapter, and he never mentions this principle, so we're all, maybe Bas knows. But so actually, just my point is, so, see, this pointer is actually not it's a virtual pointer. Okay, so it's not overwhelmed, but both is ruled out, so which is it? Now, just to mention in passing, this was the reason I even know about this, and I'm sort of puzzled still, is in Pittsburgh circa 1996, of course, like I said, Sellers had been canonized essentially at that stage. And John McDowell, among others, was saying, this is like the most important thing that's happened in 20th century philosophy. And McDowell then basically implements the Sellarsian ambiguity to a great degree. And so you're left scratching your head, because what McDowell says is, he dissolves the dilemma. The space of reasons need be neither reduced nor spooky. Okay, so it's there, but it's not spooky. It's like okay, but it's not eliminated. He says it's a naturalism of second nature. So he's like almost close to being like Bas, but then he's like, I'm gonna throw in the coda, I'm still a naturalist, to like protect himself, right? So in practice, not a naturalist. McDowell never is going to recommend the reduction. In words, truly a reductionist. So like Donald Davidson, who was one of the heroes at that time as well, for McDowell and others, it's like, okay, I'm a physicalist, but don't ask me to engage in any programs because there's some funny business that happens between the physical and the mental or the space of reasons. Okay, that was all just background foil to what Bas does, which I'm not going to claim, and this is again one of the signs of good philosophy, is we're not going to end with there's a simple answer. It's going to be more like a Socratic dialogue, where we end a little bit confused, but confused in an illuminating way. Okay, because Bas is going to make things a little more complicated for us. So here's just the summary of so far what we've seen, the top two. So to Seller's problem, there's just this knee-jerk reaction where you say, no, the manifest has priority. And you might have thought, well, Sellers had somebody in mind in the 1960s. There are still people like this, right? There are people like this in philosophy who say things like, there is definitely passage of time. It must mean actually special relativity really is false. There really is a preferred reference frame. Maybe we can't detect it. That also, of course, is very friendly with Bohmian mechanics, a certain take on quantum physics. There's people who say similar things for religious reasons even. There are people who say, well, look, we know there's genuine passage of time, so it must be there's something wrong with special relativity. So that's another contemporary version of the perennial philosophy. There's, of course, the more default view in analytic philosophy, the Spinozists. And I would say if you did a survey, if you look at the analytic philosophy literature on relativity theory, 90% is the lesson of relativity is some kind of four-dimensional block universe. That's for that specific instance just literally saying the scientific image has just totally overruled the manifest image. Sellers mentions, just to kick out to the side, a view where you just treat the scientific image as a tool, so instrumentalism, which I just mentioned here because, of course, as Kyle very quickly pointed out, or quickly at the start, and then remind us that's not the real Bas, as many people who are very casual readers of von Fraassen think that's what's going on, is it's just instrumentalism, but of course it's not. So what is going on? And that's where it gets a little fun, and for a person like me who's very attracted to nice, clean, analytic, symbolic things, this is where it gets a little scary. Because this is the Bas of the European Bas. This is the Bas who reads existentialists, who reads Husserl, for example. So there's a literature here to be appreciated that I've only partially appreciated and want to share a little bit with you. So this is sort of the next stage after scientific image and the work on quantum mechanics. So a talk that Bas gave in the mid-1990s a few times, and then wrote an article called The Manifest Image and the Scientific Image. And there it's incredible because all your expectations are completely destroyed. You thought based on the title of my talk, and you might have thought based on the scientific image, that what Bas is going to say is the manifest image has priority. Something like this, but this is not what he says. Here's what he says. He says there's something much more fundamentally wrong with the entire dialectic. There are no such things as the manifest and scientific images at all. Okay, now we're getting very confused. He says the scientific image, so it's a complicated, sophisticated article, but among the other things is the scientific image is actually not even really a candidate to be sort of a view you take, with very sophisticated examples pointing out that all of the reasons people thought the manifest image was unstable in certain senses, like it just doesn't answer certain questions, it has the ambiguities, it's actually in a certain sense worse than the scientific image. So if you actually look at, and this is where Bas uses incredible knowledge of physics to point out there's a lot of questions. So take the extremely fine-grained question, like let's think of representing space. Should I represent the space here as real numbers? Or should I take, for example, the real numbers and quotient out by Lebesgue sets of measure zero? So Lebesgue measure zero subset, and that's not something the scientific image answers. So these fine-grained questions that only if you really know the science you realize this would engage us in such profound scholasticism to try to answer these questions, which would be hopeless in a certain way. Okay, so that's the first sort of announcement of something's been wrong in the mindset of this whole thing. But it goes further than that. So this book, which I've given you a picture of the frontispiece of mine, which I hope you can see at the top, in honor of Bas. You can see some water staining because I took it camping with me. Which is like, this is the right way to read, especially this book of Bas is when you're outside, the empirical stance. And a colleague of mine said to me in the early days at Princeton, unnamed at this point because I don't want to slander somebody. He said, none of us know what's going on in that book. It's a hard book because it's, like I said, the European Bas. Okay, so here's what he does, which I actually think is an incredible sort of to use an overused corporate-like speak, a disruption. Because what Bas does is he changes the way of talking from, so analytic philosophers love static things, right? Analytic philosophers love to talk about propositions, right? Propositions are nice, they're very inhuman. And the types of propositions and possible worlds, right? All these things that don't involve us. Analytic philosophers like those. Here's what Bas does. He says, I'm going to use a word, but he doesn't say it this way. This is me interpreting him. He talks about objectifying inquiry, which this immediately sets off alarm. Actually, many analytic philosophers, they just stop at that word and they're like, that's it, the book, I'm putting it away. Because inquiry is not a word we like. That sounds like it involves human beings and humans doing something, right? And we're like, we can't handle that kind of thing, right? So this is what happens. So it's not a proposition, not a kind of proposition, not a kind of theory, not even a worldview, not even an image. It's an activity, something we do, objectifying inquiry. So he's going beyond the static categories of analytic philosophy. Now, if you think this is, fortunately, it's not going to be all Socratic aporia coming. Because actually this is, to give you the shortest autobiographical version of this, is I read this and I thought there's something so good going on here that I must figure out more. And so I started tracing backwards and trying to figure out, is there more to this? And I landed in some places I didn't expect to be, which I'll report to you quickly. But basically, objectifying inquiry, you can kind of guess what it would be in general. But basically, the way Bas puts it forward, and again, I think only someone with experience doing science could have done this, is he describes in an almost phenomenological sort of way what it's like to specify a domain of scientific objects, to ask a question of those, specifying parameters relative to which you can ask the questions. And I will say, from my point of view, it's extremely accurate to my experience. There is something like this, objectifying inquiry. I know it from experience. So I'm going to say something here about Danish people in just a second. So the one other thing, I mean, Bas does a lot in that book, but the other thing, the big point, because it would be one thing to characterize objectifying inquiry, right? That might be almost like a sort of sociology of science or even, charitable interpretation of science. But the big dialectical point of the book is that's not the only way. That's not the only way of inquiry. And so there's several kinds of examples that Bas points to, such as, I'll come back to those. But basically, he says there are concrete, recognizable instances of other cognitively significant approaches. So types of things like experience of art, experience of other people, even spiritual sorts of things. So they're systematic, cognitive, and yet not objectifying. Okay, so this next little bit, so actually where this is gonna, I have one more section to tell you about here, is, and just to be a little bit autobiographical again, is, I'll be a little even more autobiographical, just to sort of tell you the whole truth, is I actually wrote an email to Bas, and I said, what is objectifying inquiry? Where did you get this idea from? And his answer, kindly, he replied, and said, this is after Bas had retired from Princeton, so I was missing him and wanting to know what he thought. And he said, this is Kakelman's. He said this is, so go back and read Kakelman's. And I did a little bit, but I also had to be honest that I was sort of, as a philosopher of physics, getting out of my depth pretty quickly. Because when it hits Husserl, you think, okay, now it's like a real new task. But I was happy to see another thing that sort of caught my attention along the way. And that is Husserl gave a nod to somebody I was a little more familiar with, and that's Søren Kierkegaard. And so this is where this story began. And it will end in Bos, and it won't be too long, so don't worry. But the best ever circle closer, the Spinoza's successor, in some sense, was Hegel. Now, even if you think Hegel was a disaster, as many people have thought, he himself didn't think so, right? Hegel thought, I won. My mission is achieved. And what was his mission? His mission was to get rid of himself, right? In the sense of finite human being with a perspective, right? He thought going through this infinite dialectic, you eventually get rid of all your presuppositions, the circle closes. You just thought, and by that he means my Hegel's thought, and the world become one. And that's the end, right? There's no more duality. There's no more subject and object. It's just finished. So now this is me being a little bit uncharitable, but to call Putnam, Boyd, Churchland of exactly the same stripe. But there is a commonality, and the commonality is the system. In this case, for us today, the system is science. Don't forget, Hegel also called it science. We just think it's science done by scientists, not by Hegel. But it's like the Star Wars Borg, right? You just join the system. You yourself, your individuality, it's not that important. And the deepest claim being there is no choice, right? This is not about us. This is about science with a big S. And science must go on. And our job is just to serve the system, right? That's basically the picture. Okay, so now, American students, they love to read romantic, American students, they're very dramatic. And they love to read romantic figures. And I was a little bit prone to this myself, but my students still are. And so Americans know Kierkegaard. He's like the one Scandinavian philosopher Americans know. And also he's usually treated like basically like a poet. So he's like not taken that seriously. So I was very happily surprised when I heard, and there's good evidence that in some sense Husserl's thoughts about objectifying inquiry actually have a root in Kierkegaard. And then I also, being already independently in Niels Bohr, thought, okay, I must learn more about this. And actually, it's really quite incredible how the story goes, because Kierkegaard, for all his poetry and weird flights of fancy, he has one book, actually it's throughout his authorship, but one book that's very directly epistemologically related to Hegel, and that's the Concluding on Scientific Postscript. The Concluding on Scientific Postscript is basically an objection to the way Hegel thinks of science. It's saying, actually, this is just not suitable for the situation of actual human beings. So here's a direct quote. He says, the speculative philosopher, which also frequently, so Kierkegaard switches back and forth between speculative philosopher and the scientist, because this is, back then it's just the person who does science, in Danish, videnskab. And he says, the thinker who can forget in all his thinking also to think that he as an existing individual will never explain life. So this was a goal, right, to sort of forget yourself as an individual and just do the science. And Kierkegaard thinks this is actually not going to work. So he, that is the systematic philosopher, the scientist with the big S here, attempts to cease being a human being in order to become a book, this is my paraphrase, or an objective something, possible only for a Munchausen, right? So the idea of pulling up, this is very much him making fun of Hegel, right? It's like pulling up with your own bootstraps, so that after you do it, you don't need to stand on the ground anymore. You don't need to actually be a human rooted in reality. Okay, so one could go on forever about Kierkegaard, but the long story short is, for all his subjective romanticism, he makes a genuine objection to the way science was being done. He thought this is not good for humans, this kind of science. One of his reasons was, this relating it back a little bit towards physics, for example, he thought we humans are temporal beings. Hegel essentially denies that. Hegel acts as if he's reached the end of history and can just look backwards. And Kierkegaard thought that actually just isn't our situation, so we actually have to think as people who have a temporal context. Okay, so now here's the story. I'm going to go through this fast because I see the time is flowing, actually, to speak of time. So here's where actually the story gets new, different, something I didn't know before. And it's actually incredibly relevant in some sense to von Fraassen's mission. So this story, which is now going to be very brief, and I could tell you much more about it at some other time, ends with Niels Bohr. Actually, it ends with von Fraassen, but it goes through Niels Bohr. But now it goes through somebody who, very strangely, nobody had heard about. So Kierkegaard actually had like one friend in his life. So he was a very strange guy who lived alone in his apartment and alienated a lot of people. And he had one friend, a young philosopher named Rasmus Nielsen, which in Denmark is like saying John Doe, right? It's like the most ordinary name. So maybe that's one reason people don't remember him. That's this guy on the left. Now, Rasmus Nielsen, unlike Kierkegaard, who was independently wealthy and never had a job, Rasmus Nielsen wasn't independently wealthy. He became professor at the University of Copenhagen. Young, distinguished professor. He was, as most people back then, was a Hegelian. And then he met Kierkegaard. Kierkegaard radically anti-Hegelian, and Nielsen became completely convinced that Hegel was wrong and Kierkegaard was right. And Nielsen said, my career essentially will now be characterized by developing Kierkegaard's views. Now, then something very strange happens. Nielsen becomes a philosopher of science in a very concrete sense. He starts reading mathematics books, physics books. He writes a book on philosophy of math. He has these big textbooks that were used to teach the old-fashioned Philosophicum at the University of Copenhagen that are packed full of science. Why does a Kierkegaardian philosopher get into this? It's a bit of a mystery, but setting the personal issue aside here, here's the way Nielsen says what's very important is to follow Kierkegaard's thought that in the human being there are, the way they talked back then, he said there's like two modes or two moments. There's the subjective mode, that's the mode where you're personally engaged, and there's the objective mode, which of course this is just directly out of Kierkegaard's postscript. He says, Kierkegaard in his poetic way calls it the two ways, the objective way and the subjective way. And Nielsen says, absolutely right. Let's look at the empirical sciences. That's correct. In the empirical sciences, you have to objectify. And in fact, so he uses, so advantage of, I don't know what is about the linguist. So to say in English, objectify, if you're talking about science, most people have no idea what you're saying. They think you're talking about like another person and it's like a bad thing. So like you're objectifying. But in Danish to say objektivere, right? It's like, okay, back in 19th century Danish, this like makes total sense. You're like doing this sort of thing. You're like working up the object. And Nielsen says that's what we do when we do science. And in fact, he says there's this thing, he calls it the law of objectification, objektiveringsloven. There is no object without a corresponding act of objectification. And he thinks this is like the fundamental axiom of objectifying. He doesn't say objectifying inquiry, but it's core idea, this idea of objectifying. Okay, so let me just give you a little more Nielsen before we get on to the end of this story. So here's an incredible passage that I dug up, is he talks about different objectifications. So he actually does use symbols like this, which again is like a total mind bender to think Kierkegaard's self-proclaimed disciple is using a symbolic type representation in 1870. Okay, this is before the analytic revolution hits England and so on. And he says, here's what happens. He says you have an object X, and then there's sort of different frames you can objectify it in. This is before relativity theory. And he says this is not a failure of objectivity. So we won't have as human beings the one X. He says that we're never going to get there. Always what we have is these O's. Okay, so it's not a failure of objectivity. This is what it is to be objective. It is the very interaction, this Danish word vekselvirkning. It's the interaction between the subject and the object that produces the objectivity. And interestingly, that's exactly the word, Wechselwirkung is exactly the word Bohr uses for what happens in quantum measurement. And actually, so Bohr never used the word we use today in quantum theory, entanglement, but he talks about the subject being in Wechselwirkung with the object, so interacting with it. Okay, so Nielsen was Kierkegaard's friend, then professor of philosophy at the University of Copenhagen. Nielsen had a student, a guy named Harold Hoefding. Harold Hoefding, who was actually, we'll see in just a minute, Niels Bohr's teacher. So Hoefding just directly inherits a ton of stuff from Nielsen. And here's what he says, this law of objectification basically taken on word for word. He says, the subject is the Archimedean point in the theory of cognition, the point from which existence cannot be moved but only apprehended. Such a point must always be presupposed. So there's no getting rid of the subject. The subject is always there. It's just that you have to be objective, you have to be careful in specifying who the subject is when giving the description of the object. So here's, in fact, symbolism that Hoefding uses. He says, for every object, there's a subject and corresponding object to the subject, so they come sort of in pairs. Neither can be eliminated. I'm moving on fast because I have too much material. So interestingly, Hoefding, so I mentioned earlier, this whole puzzle about manifest and scientific, and in the 1960s, Putnam saying, look, if you really believe the science, it's a four-dimensional reality. Of course, this had already been discussed, and Hoefding discusses it in a book called Relation as a Category, Relation som Kategorie. Hoefding says, each observer has his own system of measure. So he's responding to Einstein's theory of relativity. He says, each observer has his own system of measurement, which is just as legitimate as another's. So it's actually taking this sort of Nielsen idea that the objectivity is not the X that is sort of the God's eye point of view, it's actually having the different points of view. And Hoefding says, in essence, the manifest image is not, he doesn't say manifest image, of course, but the observer is in fact necessary, the manifest image is not destroyed. There is in fact no description without a describer, and none of the describers here is the person who sees the four-dimensional thing. Okay, so Bohr, as I said, Hoefding's student, was in his philosophy seminars, also another argument for scientists should be taught philosophy. Bohr, as every scientist in those days, so entered the university in 1903, had a year of philosophy. And Hoefding was his teacher. And not surprisingly, here's what Bohr says in one of his papers. He says, the relation between subject and object forms the core of the problem of knowledge. And these days, under the influence of people like John Bell, they're like, oh, what is this weirdness, right? Subject, object, blah, blah, blah. Well, it's 19th century philosophy is what it is. It's, on the one hand, somebody like Hegel saying, you don't need the subject anymore, it's gone, right? It's become one in me. And people like Hoefding who said, no, actually just recognize always in every scientific description, there's some point of view from which it's being given. And so Bohr, in some sense, the epistemological lesson is to describe objectively is not to describe from the God's eye point of view. It's precisely renouncing that. Every description splits the world into describer and described. Okay, and basically he thought this is in fact how we should read quantum mechanics, because he thought this is the extreme case. In quantum mechanics, it's actual, genuine physical entanglement. So when you describe an object in quantum mechanics, you are entangled with that object. In some sense, you can't describe it from the sort of arm's length view that we normally demand of objective description, right? So as a journalist, so you don't want a journalist describing a protest who was one of the protesters, or vice versa. You don't want a journalist describing a protest who was one of the law enforcement officers, right? So you actually want somebody who can take arm's length. That's objective description. What are we supposed to do in quantum mechanics when it seems that nature is telling us you can't remove yourself? You will be entangled. And Bohr has a complicated solution, and his solution is essentially the best you can do is specify in more detail what your context of description is. And then you effectively disentangle yourself, but you only have one aspect of the situation then. Okay, so long story, and it came essentially from me trying to figure out what is going on in the empirical stance, because something seems right about it. And here's where I am as of today, is here's Bas doing some stuff that actually most analytic philosophers don't ever get near. He told me, I got this from Kakelman's. Kakelman's very clear, I got this from Husserl. I was like, okay, great, I can get on board because although I don't know anything about those guys, I know something about Bohr. And so, well, interestingly, there's sort of two paths that lead to Bas. And there's a lot more historical work to be done here, I think, to understand what's going on. Okay, so back to Bas's mission and the Kantian thing. I needed to do whatever here to knowledge, aufheben, of course, which is a word that Hegel himself later uses, which people translate into English because they're at total loss of what to say. They translate it in English as sublate, which is a word that no native English speaker has ever learned, right? So I think the whole point is you're not supposed to know what it means, okay? So but in some sense, the way I'm reading Bas here is the what looks like to some people as a harsh treatment of the scientific image is not a dismissal. It's I'm sorry, this is a little bit ironic, but almost in a sort of Hegelian way, lifting it up into a higher place, and that is back into the person. So Kierkegaard says something very interesting in the Concluding on Scientific Postscript. He says, he doesn't say objective inquiry, but this is me reading Kierkegaard through the eyes of von Fraassen. He says, when you engage in objective inquiry, you enter a parenthesis. He says, many people forget to come back out of the parenthesis and to live. And he says, that's only when you really have knowledge, is when you come back out. And he uses this incredible Danish word, which I've been told, I don't know, but I've been told there's an exact analog in Swedish, till ein. It's a great Danish word, because in English, you can only say something like to make it your own, which is like, okay, what do you mean? But people translate it to appropriate, and Kierkegaard talks about appropriation knowledge. So this is the goal, right? The goal isn't to make science great. The goal is to make us great and to use science to do it. Okay, so that certainly was Kierkegaard's vision. And I also think von Fraassen's vision, not like Hegel and not like Putnam circa 1967, which, I don't know, maybe it was politics or something. Maybe they were deluded. Maybe Putnam was deluded into thinking, if I help science, it will make America great or something. Okay, so in any case, my final summative conclusion is science is better. Something people these days don't seem to realize enough. Science is better itself when entire human beings do it. And look, the list could go on and on here. Earlier, Bas gave us his example of these great philosopher-physicists. Bohr, Einstein, Schrödinger, Newton. The list can go on. What were these? These were full people with the classic German Bildung, right? They were educated. They were humans in the world. Why are when we have trouble in science today, could it be that one of the reasons is we're not making humans to do science? We're making machines that are supposed to feed into the process. So, in short, like Höfting before him, I think that Bas, whether it was his self-appointed mission or not, has, among other things, actually contributed to the progress of science. Because what he's done is he's prepared the ground for the humans who will do science next. Okay, thank you for your patience.
Yes, and we started a bit late, so we have time for at least 2 questions, I'd say. Yes, please.
I would have one question about the scientific image and the way you see view on the scientific image in Bas. If you so according to Bas, science aims at empirical adequacy, which doesn't mean that we have the empirically adequate theory. But would you? So what I took you to argue for clearly was the rejection of the scientific image is related to the actual state of the scientific process. Would you also think that there is something in Baa's position that suggests that the empirically adequate theory is not a scientific image?
Okay, so this is an interesting thing because, I mean, this is where, so Baas clearly thinks, right, being this sort of, you know, epistemological empiricist and not semantic empiricist, right, thinks the product should be something that a person could take the epistemic attitude of belief toward, if they so chose. Now, this is actually something where I personally would probe Baas and say, but surely your considered opinion is you would recommend, I mean, you yourself, but also you would recommend to others that that's in some sense not going to be your total. Like, I think the upshot of objectifying inquiry, you know, Baas wouldn't recommend that any human thing, that's it. My cognitive state is only, I believe that. And I would just think, because they're probably the good old fashioned, you know, there are more things in the world than your philosophy, you know, knows of. The idea that there's more things in the world than, say, fundamental physics knows of. And I personally take it that's sort of one of the lessons here, is objectifying inquiry, it's only capable of producing a certain kind of the total picture that sort of a healthy human being would have. I mean, that's sort of the way I read it, and I would say that's sort of the way I feel it too. Like, I would think my view of the world would be very impoverished if I thought, you know, general relativity and the standard model, that's it. that's my view of the world, right? So.
Yes.
Okay, thank you very much. This was among the most fun and inspiring I've heard in a long time.
Thanks.
I just want to say something in defense of Hegel here. I mean, a lot more of this stuff, I think, is in Hegel. I mean, if you look at the phenomenology of spirit, it's all about that renegotiation of the relation between the subject and the object. And I think it's not very fair for him to say that he eliminates the subject. I mean, you could just as well say that he eliminates the object, but what he does is it's got to. And then we have Quine and we have Sellers, but what about Goodman?
Yeah. So, many people would say, look, many people these days think Goodman went off the deep end in the other direction, right? He's sort of considered standardly the bad guy of not looking for objective knowledge. In fact, there's a term of derision people use now called good mania, right? It's like where you become confused by the sort of Goodman subjectivity. So first of all, let me point out that, look, I actually very much have a love-hate relationship to Kierkegaard, and I tell my students this all the time because I think in many ways he doesn't abide by good rules of philosophy in the following sense, among others. He's very bad at caricaturing his opponents, right? He's not a good sort of like reader of Hegel. And I think I wouldn't consider myself to be anything like one of the better scholars of Kierkegaard, but the people I trust who are say he's actually a lot more like Hegel than he himself is aware. And a lot of his insights are like things Hegel already says on page 240 or whatever, and Kierkegaard just doesn't read it. So, but it is this sort of, often philosophers see what they take to be a small defect in their predecessor and make a big deal of it. And I think Kierkegaard is certainly guilty of that in a certain way. And so in a more irenic spirit, you could say like, you know, okay, Kierkegaard saw maybe something he didn't like, a sort of tendency he didn't like and thought it was way out on the extreme. Now, I don't know enough about Hegel myself to sort of get in the good spirit of like, you know, defending him. I will point out, I had, you'll probably be horrified to hear that I had more slides that I deleted, and I don't have an appendix like Baas, so don't worry. I'm not getting ready to go. And by the way, but actually, the story just gets more and more interesting because actually, Kierkegaard didn't come out of the blue, right? I mean, people often read like, oh my goodness, he invented existentialism. He had teachers, and actually, his teachers already had problems with Hegel, and actually one who's like I mean, all these people are like basically unknown today, but one called Sibbern. Sibbern, who was professor also at the University of Copenhagen, his actual objection to Hegel was natural science. He thought Hegel is not going to work well with the currently developing natural sciences. He's like not an empiricist enough. So it's interesting that Kierkegaard doesn't get any of that sort of empiricism, but that was like one of the initial problems.
Thank you very much. We don't have more time for more questions, unfortunately.
Okay, so we should get going with the penultimate talk of the day. So it's my great pleasure to welcome Michela Massimi. Take it away.
Well, thank you very much, James, for the introduction, and very many thanks to the Schock Prize committee and to the organizer and to Richard and to Bas, obviously, which is the reason why we're here. I'm absolutely thrilled to be here to celebrate Bas' further recognition for his lifelong contribution to philosophy of science, for which the Schock Prize is a great honor and a great recognition. Bas van Fraassen's work has been hugely influential for myself and for my intellectual trajectory. Obviously, this is a difficult act to follow after the wonderful talks have preceded me. So what I'm going to do is really to give a very brief autobiographical story of how I got here and the kind of influence that van Fraassen's view has had on my personal trajectory. And it really started when I was a graduate student. I was just saying, actually, we probably met the first time in the year 2000. It was in Scotland, as it happens, at the University of Dundee. There was a conference where also James was there giving a talk at the time. So I kind of need to pinch myself that I'm here today giving a talk, because at the time I was a graduate student listening to those big people, you know, giving those important talks. And I still remember very vividly the impression that Bas' talk, which was actually on the empirical stance, interestingly enough, left on me at the time. And I know I'm not just speaking for myself, but also really on behalf of many colleagues when I say that Bas' unfailing service to the profession over decades, a really generous engagement with graduate students, like I was back in the year 2000, and early career scholars, has been an inspiration for all of us. So I'm delighted to be here today to give my own personal reflection on a van Fraassen theme. And last time I saw Bas was in Bern for the Launer Prize in the year 2018. And at the time I was really beginning to work on my book manuscript on Perspectiva Realism that came out in 2022. And so it seems only fit that as Bas rightly receives more and more recognition for his pathfinding work, I slowly work my way through a number of topics and themes that Bas has long contributed to. And so this is the topic of my talk today: models as inferential blueprints and windows on reality, variations on a van Fraassen theme, which is really taken from chapter 5 of my book. So in music, variations are defined as a formal technique where a musical theme is repeated with changes in melody and rhythm and harmony, while also maintaining the original theme's identity. And it's a technique that allows musicians to create and develop musical ideas. So a classical example, one of my favorite pieces of music, are the Goldberg Variation, written in 1741 by Johann Sebastian Bach. And they consist of 30 variations of an aria in G minor, using different tempos and different meters. And Bach originally composed the piece for the harpsichord, but the variations have been played and transcribed for piano, for classical guitars, among other instruments. So looking at van Fraassen, a very rich and multifarious contribution to philosophy, of which we have heard already a lot so far, if I had to choose one theme, the equivalent of the aria in G minor in the Goldberg Variation, what would that be? To my mind, there is a clear contender for this role, and it's something that obviously van Fraassen has already spoken to in his lecture, and it really is the view of scientific models. So back in the 1980, in this seminal book, The Scientific Image, Van Fraassen laid out a profoundly influential view of scientific models. What 47 years later, with wisdom of hindsight, was really revolutionary in Van Fraassen's move at the time was really a shift away from what up until the moment had been the overwhelmingly central role that scientific theory had in philosophy of science under the syntactical view. Obviously, there were a precursor to this move. I'm thinking of Patrick Sappi's hierarchism model in the 1960s and the broader revival in the 1980s of experimentalist approaches to science that permeated the work of contemporary philosophers. I'm thinking of Nancy Cartwright, I'm thinking of Ian Hacking and others. But there is something, I think, unique about Van Fraassen's take on scientific models. And to my mind, he has been really the first to entrust scientific models with a degree of epistemic authority that up until that point they had been historically denied. In the scientific image, the ability of a theory to save all the observable phenomena and therefore to qualify as empirically adequate depends on scientific models having empirical substructures that fit the appearances. And I believe Passadia, his own G minor aria, if I may use the analogy with Bach-Goldberg variation, really originates from his familiarity with the literature in logic and formal methods. Now, this is a long quote, so apologies, a bit bewildering, but I'll very briefly give this quote from page 64 of the Scientific Image, where Bassa says, "I've proposed a new picture, still quite shallow, to guide the discussion of the most general features of scientific theories. To present a theory is to specify a family of structures, its models, and secondly, to specify certain parts of those models, the empirical substructures, as candidates for the direct representations of observable phenomena. The structures which can be described in experimental and measurement reports we call appearances, and the theory is empirically adequate if it has some model such that all appearances are isomorphic to empirical substructures of the model." I'm certainly not the first to propose this picture. You can see it in the work of all those other people that he mentioned, including Toraldo di Francia and Maria Luisa Dalla Chiara. So the idea that models have parts called empirical substructures, which are candidates for the direct representations of observable phenomena, was going to be hugely influential in the field of philosophy of science. And indeed, like the aria in G minor in Bach-Goldberg variations, this idea was going to ripple down into myriad variations in tempo and in meters over the following decades, which to my mind include the following among many other examples one can think of. Scientific models as mediators, the natural computer simulation, ontic structural realism, the debate about scientific representation, the epistemology of modality, scientific perspectives as hierarchies of models, measurement and model-based metrology, adequacy for purpose view for models. Now, despite very different metaphysical stances that are behind each of these trends, and despite remarkable differences among some of the colleagues that have been defending some of these different views, I think the germinal idea that to my mind has really prompted this whirlwind of philosophical creativity in the past 50 years can be traced back to Van Fraassen's characteristically understated introduction of a new picture, still quite shallow, to guide the discussion of the most general features of scientific theories. And so in the remaining of the time, what I want to do is to somehow add my own bullet point there, my own list of variation on a Van Fraassen theme, and present very briefly some of my work on perspectival realism, and in particular my view of models as inferential blueprint that is really in debt to this idea of Van Fraassen. And again, I want to do it by going back on an autobiographical note to one of my very, very first papers back in the year 2007 in BJPS. It's also been the last paper I published in BJPS, must be said. It's been a long time, 20 years, although I was an editor at some point. But so in that paper, that has a very pompous, typically mature title of PhD students give, Saving Unobservable Phenomena I went back to Van Fraassen viewing the scientific image, and I wanted to investigate the, quote, process of construction of data model in particle physics and explore the nature of the constraints underlying the introduction of new theoretical quantities at the most fundamental level of the quark theory. And so I said, in Van Fraassen words, this is an exceedingly subtle subject for philosophy, and what I offer is only a tentative analysis that we raise some question for an empiricist, and the conclusion should be read as a preliminary contribution to a still largely unexplored area. So little did I know myself when I wrote this paper almost 20 years ago as postdoctoral student on the discovery of the J-psi particle in particle physics, that the study of models in particle physics and cosmology was going to occupy a big chunk of my time in the following decades, and that effectively was going to lead me to my very own variation on a Van Fraassen theme. And so I really wanted to understand, this is what attracted me as a PhD student, as a postdoc. I wanted to understand why models well known for involving idealization and abstractions are nonetheless so important for delivering knowledge about the world, and in particular, a particular flavor of knowledge, which is modal knowledge, something that the epistemology of modality have been discussing for some time. And while much had been written on the metaphysics of false yet explanatory models and how idealized models represent their target system in useful ways, understanding how modal knowledge is obtained from scientific models remained a relatively underexplored topic when in 2016 with my ERC project I started working on the book. And so my goal was really trying to get clear about the procedure through which some classes of models deliver important forms of modal knowledge. And some of the papers that led to the book, I was doing reflections on the use of particular classes of models in particle physics. So with my ERC project and my PhD students and postdoc, we went to CERN and we were kind of interviewing particle physicists and asking them how they use their models to explore new physics, potential new physics beyond the standard model. And so one thing that kind of struck me from those conversations is that despite the emphasis on representation that is in the philosophy of science literature, most of those models could not really be said to have primarily or exclusively or mostly, or however you want to call it, a representational function, because technically we don't even know whether there are those objects. They are using those models to explore possible new physics that for all we know might not exist. So that's the idea behind some of these early papers, also with my postdoc at the time, Casey McCoy. Really the idea that the models have an exploratory function, have the function of exploring the space of possibilities, and ended up arguing for this exploratory function. So I ended up defending this view that is fully articulated in my book, in chapter 6 of my book, that we use models and particular classes of models really to imagine or conceive non-veridical scenarios about the target system with an eye to delivering modal knowledge about what is possible. And I call these classes of model perspectival models. I want to clarify, I'm not saying that all models are perspectival models. As I said, my interest really started with these particular classes of models used in cosmology for dark matter or in particle physics for exploring supersymmetric particles. And so I returned to them in my book in chapter 4 and 5, where I introduced this notion of perspectival models, and also I made a distinction between perspectival models and perspectival modeling. So what's the distinction? So perspectival models are a variety of scientific models. As I said, it's a subset of a much larger class of scientific models. Perspectival modeling, as I use the term, is not restricted to scientific models exclusively, but it refers to the situated practice of modeling reality that is typical of communities that are historically, culturally situated, communities that may use specific instruments, specific experimental approaches, technological apparatuses, and so forth. And they use those those techniques to make inferences from the data to the phenomena of interest. That's what I call perspectival modeling. The idea that we don't have a God's eye view, the idea that there is no objectifying inquiry in a way. Our inquiry is always situated, is always from a human point of view, is done by human people at a particular historical point, which may sound trivial and banal, but the question is, okay, if you start from that as your starting point, right, some kind of Kierkegaardian starting point, or Borean, actually, I have another story about that, because my laurea was on Bohr, and actually I wasn't born in Kierkegaard, so maybe there is the Danish road to Van Fraassen, but anyway. So if you start with that assumption, then the interesting question for me became, where to go from there? Can you be a realist about science, or are you stuck with some form of, I don't know, idealism, anti-realism, instrumentalism, however you want to call it? So that became the topic of the whole project. Now, it's a long book, it's 400 pages, so apologies, it's going to be a whistle-stop tour through some of the highlights of the book, where I discuss a series of case studies in different chapters, chapter 4, A, B, and C. And I'm just going to give you some of the highlights of those case studies. So, for example, in one chapter, I was interested in looking at how we make inferences from data to phenomena such as climate change through the situated perspectives of different epistemic communities. And those communities may range from dendroclimatologists, the people that work on tree rings to make inferences about past droughts, to communities of paleoclimatologists that study isotopic components in corals, for example, to study changing temperature in the ocean, as well as people, actual modeler, people that build models and use those data to make inferences and projection about climate change over the next 100 years. I had another study in chapter 4C where I was looking at the phenomenon of children difficulties with learning how to read and write, and again looking at different communities, the communities of the developmental psychologists, the kind of data that they use to make those inferences, as well as the community of the educationalists, people that use very different kinds of data to make inferences about how to best change educational approaches to help children achieve those goals, as well as a case study that I'm going to say a little bit more about in a second, namely the case study about the phenomenon of nuclear stability and how we came to make those inferences about the existence of particular atoms which are stable in nature, they're abundant in nature, using a plurality of situated modeling practices. So given this terminological distinction and particular way in which I use the term perspectival modeling, one needs to tread carefully here, because what makes some modeling perspectival is not that each model involved in the wider modeling technique offer a different perspective on a target system, as one might think on a kind of colloquial basis. What makes some modeling perspectival is instead that it's embedded into the situated practice of particular communities and fulfills this exploratory function in delivering knowledge over time. So I'm going to give you very briefly an example from chapter 4A of my book, where I was looking at the phenomenon of nuclear stability. So why is it that we know that there are some atoms in nature that are more stable than others, and those atoms also turn out to be very abundant in nature? Well, in the period between 900 and 924, a number of communities and their situated practices, what I call perspectival modeling, made possible to establish that there was this modally robust phenomenon that we call nuclear stabilities. And they came to the conclusion that atoms that are particularly stable are atoms that have particular magic numbers of protons and neutrons. If you want to know what those magic numbers are, they are 2, 8, 20, 28, 50, 82, 126. So atoms that have those magic number of protons and neutrons are particularly abundant in nature, and they are particularly stable. Now, it's a fascinating piece of history because how we came to the conclusion involved really knowledge of, actually, you'll be surprised, not necessarily nuclear physics, but people that really were working on rocks and silicate. And the work of Washington on petrology was particularly important in establishing that there was this data about particular abundances of nucleids in varieties of rocks. But also people like Victor Moritz Goldschmidt in Norway that was working on cosmochemistry, so abundance of chemical elements in meteorites, as well as scientists like Ramsey that was measuring percentages of krypton and xenon in the atmosphere. And then there were the experimentalists, people that were just building instruments like Francis Aston mass spectrograph. That was really an important tool for establishing those measurements. So there was this plurality, this flurry of situated practices in petrology, in cosmochemistry, as well as in nuclear physics, that in a way led to the inference from this plurality of data about specific atoms to the existence of a phenomenon, which is nuclear stability. So what makes those inferences perspectival is the fact that really, in a way, they are, as I said, situated. The perspectival modeling is situated in the knowledge of those specific community in the early 900, the 1910, 1920s, the particular tools and instruments that they used to make those claims, but also the methodological epistemic principles that they adopted to justify the reliability of their claims of knowledge, so specific norms in petrology, in crystallography, nuclear physics, and so forth. And it really took almost a decade to realize that those data were evidence for something as important as nuclear stability. And what was really needed was, at this point, yes, a model. You need a model that allows to collect that data and use that data to make inferences to a phenomenon, what we call the nuclear stability. That model was introduced by two scientists, Hans Jensen and Maria Gopper-Meyer, in 1948. And so in the book, I briefly go over a number of models for the nucleus that were available in the period between 1930 and 1950 and their complex interplays. And this is a class of models that, in my mind, are a good example for what I call perspectival models, in this sense that they are models used as part of a wider perspectival modeling practice of people making inferences from data to phenomena in a way that is situated and exploratory. There are several of those models. I'm not going to go into any of those details. I'm just going to mention, yes, GAMO, liquid drop model, but also Bohr compound model of the nucleus, Catherine Way, odd particle model, and Jensen and Gopper-Meyer shell model, which was eventually awarded Nobel Prize for Physics in 1963, making Maria Gopper-Meyer the second woman to receive the Nobel Prize for Physics after Marie Curie. So very briefly, the idea of the shell model is that you have to think of a nucleus as consisting of shells or orbitals where protons and neutrons sit according to those special magic numbers that scientists have been collecting evidence for. So why there was this plurality of model? You think, okay, how is this related to realism and perspectivism and Bas van Fraassen work on models? I want to mention here and also give my homage to another philosopher that is no longer with us, but whose work has been influential for me, and that's Margie Morrison, who in a paper in 2010, but also in her 2015 book, made a fairly scathing remarks about model pluralism in science and what can be said about this plurality of models in any particular context of inquiry. There's a long story behind this quote, which I'm not going to give you. Morrison was really not so much responding to Bas about engaging with the Ron Giri's view, which in some way I think is related to the aria and G minor of Van Fraassen ideas, the idea that we use models to represent the target model in a way that reflects the intentions of the agents and is perspectival. And so Morrison had this very skeptical view where she said, well, okay, if you take Ron Geary's view seriously, that we need model pluralism because knowledge is always situated, is perspectival, then we are no farther ahead in understanding nature. If I ask you, tell me what is the nature of the atomic nucleus, we seem to be at loss because we have a plurality of models that seems to be making different metaphysical claims about the nature of the nucleus. None of them seems to be particularly the right one. And therefore, we are no farther ahead in our understanding of nature. So that got me thinking, and also that's also another reason why I started working on this topic, because I wanted to develop a way of thinking about how to reconcile a sort of pre-philosophical intuition I had about realism with this sort of not God's eye point of view that was really my starting point. And in a way, it's an intuition that I take from Van Fraassen, and if you like, from the Danish road to Van Fraassen, this idea that we don't have any objectifying inquiry, we have a human point of view, a human agent that is very much center stage if we want to understand our knowledge of nature. And so my reply to Morrison ended up being a reply where we shouldn't really think of models as providing a one-to-one mapping between features of the model and features of the target system. We should think of those perspectival models as part of broader practices, as having really an exploratory function. They allow the nuclear physicists to gain knowledge of the nuclear structure at the time where there were speculations about the nature of the nucleus. So people still believed they consisted of alpha particles at the time where quantum chromodynamics was not even discovered. So those plurality of model played an important role in the historical evolution of our knowledge about the atom. And therefore, they're not perspectival in the sense of representing the nucleus from different points of view, or in the sense of offering incompatible images of the same objects, but they are instead perspectival representation because they open up a window on the reality of something that we are very much exploring. We are in the dark about the exact nature and structure and so forth. And despite our partial and limited and inevitably piecemeal approach to it. And so I'm returning here to Bas and really to his work here on the 2008 book on scientific representation, paradoxes of perspective. They also had a massive influence on me in thinking about those questions. So that book by Bastiaan Fraassen really got me thinking about what is at stake in the idea of representing from a particular point of view. What's at stake in the idea of perspectivity. So as I said, there was this tradition coming from Ron Geary, where scientific perspectives are families of model, but there was another tradition that I think, again, is connected with the first one in an interesting way, and it's really the tradition that Bas was exploring in his book. And so, building on that, one of the starting point for my own book became the idea that there may be two ways of thinking about what makes a representation perspectival, or what makes a representation of a specific target system, like the atomic nucleus, perspectival according to models. There's a perspectival 1 and perspectival 2. So a representation is perspectival because in a way, yes, it's always situated, it's always from a particular point of view. But it's also perspectival because it's drawn towards one or more vanishing point. So again, if you go back in the history of architecture, the history of art, the innovation of perspectival drawing was precisely the innovation of having one or more vanishing points to which it's possible to draw lines that are coplanar, and it's possible to make the illusion of a three-dimensional space on a two-dimensional canvas. And so in chapter 2 of my book, I started exactly with Van Fraassen reflection on this idea of analogy between art and science and what it means for a representation to be perspectival. And I ended up concluding that those two ways of thinking of perspective and perspectival representations were not incompatible. They were just two sides of the same coin. Any representation is perspectival in the first sense only because it's really perspectival in the second sense, we have the impression, the illusion of an image that is drawn from a particular angle, like the beautiful Arnolfini portrait mirror image that seems to be painted from the back, from behind, where we can see the whole room where the betrothal is happening. But that's only because Van Eyck has been very skillfully using vanishing points to draw the line and to create this illusion of a space on a two-dimensional canvas. And so out of metaphor with art, we can ask how models of the nucleus provide a perspectival representation of the nucleus, its internal structure, its isotopic stability. Along the same line, we use models, we use something like the shell model of the nucleus, among others, to explore what's possible about those objects. And that means we can also start asking specific questions. We could ask questions like, can alpha particle natural radioactive chain end with the element thallium rather than element lead? And now we know that there is a negative answer to that question. And we know there is a negative answer because thallium has a number Z81, which is not one of those magic numbers. So a model like the shell model of the nucleus with the magic numbers allows scientists to ask questions about what is possible about their object under study, even if their knowledge about the object may still be very partial, limited, and piecemeal and not complete. It's from a human point of view, not from a God's eye point of view. Or you could ask whether there could be new short-lived nuclei with very large neutron excess, and the answer is yes. The model tells me that there could be such objects, and investment can be spent in trying to find them. So to be a perspectiva realist then about, for example, the atomic nucleus in the period between 1930-50 means really to engage with this plurality of inferences about the nucleus and to use models to achieve that result. So obviously that was the general intuition I had about how we use models to make those inferences. What was missing and what I felt I need to address in the book was really to provide some sort of account of what are models and what kind of metaphysics, if you like, of models can support this sort of view of models as having an exploratory function. So in chapter 5 of my book, I ended up defending the view that we need to think of perspectival model as inferential blueprints that allow scientists to make inferences about from a range of data set to what I call modally robust phenomena. I'm not going to go into the story of what is a modally robust phenomena. Happy to talk about that if you like. That's the topic of the second part of the book where I try to spell out the kind of realist position. But very briefly, the idea is we need to think of models as some kind of inferential blueprints that support form of reasoning, such as indicative conditionals with a suppositional antecedent. So let me give you very briefly the intuition, which is inspired once again from the analogy with art. Architectural blueprint mark a turning point in the history of architecture because they made it easy for the first time to go through various iterations of the same design before the introduction of the xerography, and they allow to introduce changes to the original design, delete feature, tweak, the height of the roof vis-a-vis the height of the door, and so forth. And there are a number of elements at play in this analogy of models as blueprints, inferential blueprints. First of all, blueprints are perspectival representations because each of them represent the target system. In the example I just gave, the house, the building from a specific vantage point. The representation is distorted. It's not a perfect mirror image. They are the starting point of collaborative effort in the design, and they act as inferential tools in the sense that a blueprint is a medium that allow communities to exchange information over time and make relevant and appropriate inferences about the objects that they want to build like a house. So likewise, perspectival models, again, think of the shell model of the nucleus, offer perspectival representation. They too offer representations that are distorted, and they too are collaborative efforts of different communities. And ultimately their function is to make possible those relevant and appropriate inference about the target system. So like in the case of architectural blueprints, where you have carpenters and joiners and masons, they are able to use those architectural blueprints to make inferences about how tall should the building be, what's the ratio between the height of the door and the height of the window, and so forth. Likewise, we can use models to make those sort of inferences about what's the relation between specific quantities of interest. It's a long story, which I cut it short because I'm aware that I'm running out of time. I see those inferences as very often couched in the terms of indicative conditional that have an antecedent where, in a way, we have a supposition. That's what the model does. It allows us to conceive or imagine what could be the case about the object under study. So imagine the nucleus as if it was a set of shell where protons and neutrons sits according to magic numbers, and the main clause contain an epistemic model. So following Angelica Kretzer's view on epistemic models. So how do I do that? It's a long story, so I'll maybe cut all this, but ultimately I ended up trying to build and go beyond a vast literature that exists on conceivability and modality in epistemology, and trying to provide some sort of constraints of what is often an unbridled notion of conceivability that we find in the epistemology of modality, where sometimes the type of conceivability takes the flavor of close your eyes and imagine a world where you can see a purple cow, or close your eyes and imagine a world where you can see a transparent ion. That's not what I mean by physical conceivability. Physical conceivability is something that has to respond, comply with the state of knowledge of a community at the time. So it was physically conceivable for Maria Gopper-Meyer to think of the nucleus as having shells because of the knowledge at the time, for example, about the electronic structure that she was drawing the analogy for, but it wasn't conceivable for Rutherford. He didn't have that knowledge at the time, even just a few decades earlier. And the other important element is consistency with the laws of nature known at the time. So ultimately, I argue that the modal gap between physical conceivability and knowledge of possibility is not filled through essential property ascription, and I parted my way with Kripkean essentialism. In fact, the old view is anti-essentialist, anti-foundationalist, and I ended up arguing that perspectival models should not be entrusted with the task of ascribing essential properties to the target system, that going down that road is the wrong way to go, is exactly what caused the worry that Margaret Morrison was flagging about incompatible metaphysical image of the same target system. There are objections, which maybe I'll skip, because I just maybe conclude. Yeah, how are we doing with the timing, James? Other 4 minutes, okay. Then maybe I'd say something, maybe I'd say the worry. Shall I say the worry? Why not? Why don't we say the worry? Lots of worry. So, okay. So one worry that someone might have here, okay, is that physical conceivability, so understood, may accrue cheaply given the reference to the known laws of nature. So someone may worry, okay, you're parting your way with Kripkean essentialism, but ultimately isn't there a risk that modal knowledge can easily be delivered in the name of physical conceivability? So one can say, imagine the knowledge claims of modal flavor that lead can be transmuted into gold, right? I mean, that's not available to us today because we now know that lead is one of those stable elements with magic atomic number 82. But the medieval alchemists, they didn't have that knowledge. They didn't have knowledge of those specific laws of nature. So it was physically conceivable for them to think of a possible transmutation of lead into gold. And those sort of counterexamples are ubiquitous in the history of science. So how to proceed here? So one of the things that I tried to address, not sure how successfully, but anyway, was really inspired by work by Polito on past modalities and how to think of the relation between physical conceivability and modal claims in terms of a time-sensitive epistemic accessibility relation. So you can think of points in time where this exercise of using the knowledge that we have available at the point in time, situated in the community, with the with the laws known at the time by the community, open up, give epistemic access to a range of modal claims, which are all the various branching paths that you see at point TC. But as time goes by and we reach point TM, as the state of knowledge changes, this physical conceivability gives epistemic access to another range, or if you like, a subset of modal claims, because now we know more and we maybe have changed some of the laws of nature. So some of the claims of modal flavor that were available before may not be available anymore now. So some of the paths taken by the communities are the one with the blue crosses, and some of the others that remain gray are the paths not taken, things that were physically conceivable at the time but didn't end up being explored. And ultimately, this is the image I ended up defending in the book of perspectival realism as some kind of not a cumulative, linear accumulation of knowledge, but a zigzagging that we have through history using a specific tool, experimental apparatuses, conceptual resources, and models to advance claims of knowledge or modal flavor in a way that is fallible and revisable as time goes by. And this is definitely the last slide. I'm going to conclude because I want to return once more to Fraassen work. And so we've heard a lot today about the scientific image, but I want to have those two books. I'm glad that Hans brought up the empirical stance, because also that's the book that in a way marks a bit of a turning point in my own autobiography. The empirical stance and scientific representation, because the seeds of an idea that Van Fraassen planted on me when I first read those books decades ago, I think stays with me to these days. And even if I might have ended up defending ultimately some kind of form of realism about science, that shouldn't really detract attention to what I share with Bas in the use of scientific models and their ability to latch onto data and appearances. So Van Fraassen's view really set me on an intellectual path that I've creatively explored as a philosopher over the past few decades, and for that reason I'm very grateful to his work and all that has made possible in philosophy of science. So thank you.
Wonderful, thank you, Michela. So we have between 10 and 15 minutes for questions. So just put your hand up if you want, and I'll put you on a list. We'll start with James.
Oh, thank you, Michela. I was puzzled because I thought that you were talking about modal knowledge in a kind of objective or like in the world sense. But then you said that these modals were epistemic. Mm-hmm. Which is it?
The latter.
The latter.
Yes. So no, thank you for the question. So because the view of perspectival models is really part and parcel of this broader account that I call perspectival modeling, and which is really the starting point of the realist commitment I want to defend. Ultimately, what I'm talking about are human agents that think and talk in modal terms when they use models to make inferences from the data to the phenomena of interest. So we are talking about how the atom could be in the light of the shell model of the nucleus, and we are making a series of inferences to phenomena that are modally robust. So what does the heavy lifting of perspectival realism is not the epistemic model in the indicative conditional, if this is the spirit of the question, if I understood it, but it's actually the notion of phenomena, which I haven't said anything about today because that would require a different talk. So what does the heavy lifting is the kind of objects that we end up inferring from the data using those models through suppositional reasoning of this nature. And then I have a view there of phenomena as being modally robust, that we can talk about if you like, but that's what does the realist heavy lifting in the view. And it's all the topic of the second part of the book, so chapter 6 onwards, on which I didn't say anything today.
So do you think I mean, my understanding of Bass's view of modality is that modality, the only necessity is verbal necessity, roughly, is the slogan. And then the way that he describes it is, in our theorizing, we raise some regularities to the status of laws, and then what we, counterfactuals that we assert or modal claims that we make are all relative to that raising of some regularities to the status of laws, but that raising of some regularities to the status of laws is entirely due to us. It's nothing. It doesn't answer to the world in any way. So, is that your view as well?
No, not that particular view. So I wouldn't say that laws are regularities that we have raised to the status of law. I mean, Basti should reply and kind of defend his own view. But I have a view of laws of nature that is, in a way, kind of similar, related, but I don't think it's what you have in mind here. So it's really, if you ask me what is a law of nature, so again, I make a distinction between law-like dependencies and lawhood. And I'm broadly in agreement there with a view like, David Lewis, best system analysis. So the idea that, if you like, yes, there are empirical regularities and things that we call law tend to be, if you like, yes, axioms or theorems in a best system. What I disagree about with David Lewis is the idea that there is one best system. So I think that there isn't one single best system because there is no human mosaic on which we can build the best system. So I have a perspectivalist view of how notions such as simplicity and strength could be balanced out in different ways in different historical periods. So you can't really say there is just one single unique best system. So I have a view of laws that is itself very much perspectival, and in that sense I don't think Basti would agree with their specific features. But I don't know whether they answer your question.
Thank you.
Peter.
Thank you. Highly interesting talk. So I was wondering about both the concept of a model itself as you use it and the concept of a perspectival model, how that relates to the distinction between empirical content as the level of empirical adequacy and as opposed to the level of theory that goes beyond the level of empirical adequacy. So would it be the case that perspectival models are used only for the empirical transcendent part, or would it be that would it possibly hold for models in general, on your view, on what we model?
Yeah, thank you for the question. So mine is a bit of a peculiar type of realism because throughout the book I don't really talk about scientific theories. And normally that's the way in which scientific realism has been cashed out as the aims of science is to deliver theories that we believe to be true or approximately true. And I don't really have anything to say about that because, and this is where I really share the aria in G minor with bass. The whole exercise starts with models and the ability of models of having empirical substructures that latch onto something in reality. So I share that with the empiricist approach. Now that something is something that I call stable events in nature. So I believe that there are stable events that are part of the fabric of nature, and if you like, it's really our ability to latch onto those stable events that ultimately explains how different communities may use models, and sometimes more than one models, to reliably make inferences about modally robust phenomena that are not figment of our imagination. They are actually robust in a modal way, in the sense that they can be inferred and re-inferred more than once by different communities using different data to phenomena inferences. So that's a kind of realism ultimately I defend. It's a realism at the level of the modally robust phenomena without transcending or going above the empirical substructures. It's a bit of an unorthodox book, because in fact, that's how normally people complain. It's like, it's not really realism because you don't say anything about theories. And I don't say anything about theories because I think actually this is where I really share Bas' view that maybe we should be voluntaristic about what we want to say, whether we want to be, realist or empiricist or perspectival realist. And what really matters is that we have a story to tell about how those models are used in specific contexts to latch on to something. In my case, it's what I call stable events that eventually become phenomena. I have a Kantian Borgian story about what the modally robust phenomena are, that to me are the objects of realism.
So are models heuristics on your view?
So yes, so when I say that they have an exploratory function, I want to capture this idea that we use them in a heuristic way to make those inferences, especially in areas where our knowledge can be patchy, incomplete. So that's why I was mentioning the example of the atomic nucleus in that period, because there were still lots of speculations about the atomic structures and so forth. And that kind of echoes with the way in which scientists in contemporary physics have been using some of those models to explore possible new physics, which for all we know may or may not be real, right?
Okay, thank you.
Thank you.
Thanks. So when Bas was talking and distinguishing empirical support from confirmation for us, in characterizing what empirical grounding required, right? There was the worry that our efforts to provide empirical grounding for theories presuppose the theories for which they're supposed to be trying to provide empirical grounding, and that's what made this requirement of concordance or coordination so important. It's that we have to keep finding the same value when we look in these very different ways. Is that a good model or way of thinking about the perspectival character of the kinds of models that you're talking about? Is that a natural way to characterize their perspectivality, or is that not helpful?
Yeah, I'm not sure I see the analogy quite as much, because ultimately perspectival realism is not so much a view about confirmation or empirical support. It's more of a view about what I like to think of as a project in the epistemology of science, how we use models to make inferences that are reliable and relevant and appropriate, that can be inferred and re-inferred more than once. But confirmation or questions about confirmations are not really questions that I address.
Yeah, so we could set that aside, but the what looks like the perspectival character there is that attempts to provide empirical grounding are sort of presupposing the theoretical apparatus that they're making use of in order to relate the results somehow to the theory.
Yeah.
And I'm wondering if is that the kind of perspectivalness
What is perspectival in it?
that they're presupposing their own sort of rules of the game and foundations? Is that a natural way to think about it?
Yeah, yes, I think so. Again, I didn't give the definition today that I use in the book about what I mean by scientific perspective, and in a way that parts its way from, I don't know, Giri's view, for example, is that for me a perspective is not just a family of models, so there is more. And what's more is really the wider embedded practice of the community. So I really want to call it in terms of empirical grounding. I wouldn't call it empirical grounding because I have association with the notion of grounding. They are much more metaphysical than what I have in mind. I really have a fairly mundane idea that it's just knowledge that is historically, culturally situated, which, as I said, may sound tautological and banal, but the question is, if you take that as a starting point, the question really becomes what kind of realism is available within those boundaries, because the classic scientific realism is no longer available and various flavors of metaphysical realism are not available. So what is the kind of realism that is available, starting with that view?
That helps. Thanks.
Wonderful. So if you would join me in thanking Michela.
You tell me when I'm 2/3 of the way through. Huh? After 30 minutes, so I get 45 to it.
So we're at our final session, and our next speaker is Professor James Ladyman, who will talk about science, empiricism, and belief. Please, James.
Well, if I can make the clicker work, how do I go back? And now just going forward.
It's clicking its head off there.
Is that going back? No. How do I go back?
It's
The other button.
The one below, yes.
Oh, thank God for that. Right, okay. Thank you all. You start as you mean to go on. So, first of all, I'd like to extend my thanks to Richard for inviting me, and to all the organisers, and especially, of course, to Bas. I wouldn't be here if it wasn't for him in so many ways, not least because I was lucky enough to be included in the writing of a paper with him when I was still a graduate student. When I applied for my first temporary job at the University of Bristol, I think people were very impressed that I had a paper with Bas van Fraassen. They said as much. Probably wouldn't have got the job without it. I was there for a 1-year temporary, and then there was a permanent job, and I've been there ever since. So definitely wouldn't be here without him. And I will be putting more pressure on Bas's views than some of the other speakers. I hope that everyone will take that in the spirit of homage. And also, along the way, I will be saying in how many respects I think Bas, about how many things I think Bas is right. And I'd also like to point out that, you know, lots of philosophers are recognised as great without really having persuaded people of very much. And I think Bas has persuaded people of a lot. He's persuaded people to take non-realism seriously. In the scientific image, it says somewhere, aren't we all scientific and realists nowadays? And I don't think that someone writing about that topic would say that now. I think there's many more anti-realists. So in that way, he's been successful. He's been successful in promoting the semantic view of theories that we've already heard about, voluntarism in epistemology, many other things in philosophical logic, supervaluationism, and so on. But perhaps most importantly, I think he's been successful in persuading people that he is empiricism. And that's something that I actually disagree with. So I'll be pushing back a little bit on Bas's widely recognised ability to speak for empiricism, and perhaps persuading you that an empiricist nowadays, I think, as a result of Bas's influences, but not just Bas's influence, people think of like realism, contrast, empiricism. And I'll be suggesting that maybe we shouldn't think that way. Okay, good. So I'm going to, any of you heard my talks before, there's a point at which I skip through the last 25 slides because I've got too many. So that might happen. I'm going to say some general things and I'm going to talk a bit about 19th century chemistry. And one of my lessons, I think, is that it's productive and helpful for us to take forward the realism debate and other debates in philosophy of science by thinking a bit about chemistry and not so much about physics. But before we get to that, I'll just start with a bit of preamble. I mean, although, Bass very much says it's not about belief in unobservables, it's about the aim of science and so on. But a lot of the time we do want to know, are we supposed to believe in certain things? And then we expect science to tell us. And indeed, in many times in the history of science, the main subject of debate is whether something exists. And here are some examples. Now, in each case, of course, the onset question is tied to the merits of, tried to question about the merits of particular theories. But Bass says, look, the question of belief in an entity is not the same as the question of acceptance of a theory. I mean, in general, that seems right. But they're not as unrelated as perhaps he might try and persuade us. So, in the history of science, success of certain theoretical hypotheses has in general led to scientists and other people believing in lots of things that they didn't believe in before, but not the Philosopher's Stone or phlogiston or Vulcan. And we'll talk about atoms in a bit. Okay, now I think another thing that's important about ontology and science is just the scale of ontological expansion in science. So, moons of Jupiter, outer planets, 1 million minor planets, 4,000 comets, millions of meteoroids. In general, the universe is much more richly structured and populous and bigger and older than was thought prior to the development of the science we have now. And it's undeniable, I say, even by philosophers. I'm waiting for someone to say, deny this afterwards, but I claim, you cannot deny that the number of entities and kinds posited by our best science now vastly exceeds the ontologies of all previous epochs together. So, yes, acceptance of theories and believing in things aren't the same thing. Nonetheless, I think this is an important feature of science, right? That it has involved massive ontological expansion. And scientific realists, of course, take all this at face value and say we know about these unobservable entities. Now, along with this ontological expansion is a kind of categorical expansion. So we don't just have more entities, we've got more properties, more relations, more processes, more kinds. Also a very rich and variegated modal structure to science. So there's various kinds of causal structure, there's various kinds of nomological structure, symmetries, equilibrium explanations. And clearly then, as well as expanding its ontology, science has expanded its causal and nomological complexity. And scientific realists often take this at face value as well, as knowledge of objective modality. So Van Fraassen says, look, you don't have to take this at face value on either count. Right? So on the one hand, agnosticism about unobservable entities, and on the other hand, repudiation of objective modality are both reasonable and compatible with being a scientist. Not just compatible with, being a consumer of science, but actually being fully involved in the scientific enterprise. So, as we've heard, constructive empiricism is not an epistemology, but as Kyle very clearly pointed out, nonetheless, constructive empiricism is pervasively misunderstood. Right? Even today I read a recent article, someone immediately saying, well, of course, scientific realists think we know about unobservables and constructive empiricists think we can't know about unobservables. But Van Fraassen eschews the ideas of knowledge, justification and warrant completely. And that's a paper to which he alluded, I think makes that very clear, that the paper, The False Hopes of Traditional Epistemology, but that's very much the part of the theme of laws and symmetry. Yet the standard definition of scientific realism is not about, realists don't define their view in terms of the aims of science. So whilst Bass says realism is a view about the aims of science and constructive empiricism is a rival view, the scientific realist often says, no, realism is just the view that there are unobservables and we know about them. And so there's a kind of talking at cross purposes here, right? But I think that scientific realists say, look, what I really care about is that we should believe in the entities mentioned above, and more generally in the ontology of our best science. And they argue that skepticism about unobservables is unreasonable, and they demand belief. Right? And Van Fraassen says, no, sorry, I forgot the date of empirical. When's the empirical stance? What's the 2000? 2000, yeah. So in the empirical stance of 2000, Van Fraassen says, well, you can adopt the empirical stance, you can adopt the materialist stance, there's no neutral ground to adjudicate between them. And insofar as scientific realists take realism to be a voluntary position, then I think they concede to Van Fraassen. And many do now. Nonetheless, despite this business about axiology, not epistemology, the scientific realism debate at its heart is still about whether being unobservable to the human senses matters. Right? Does it matter epistemically? Well, I'm going to also ask, does it matter in respect of the aims of science? Now, what is observable is not what's actually observed. And so Bass, anyone who's a constructive empiricist, has to have something to say about the modality of observability. And Bass tells us, well, it's science that tells us about what's observable. So here we think about science and modality, and Bass brought modality to the fore in discussions of models and realism in philosophy of science. But he argues that scientific theories raise some regularities to the status of laws on a pragmatic basis. We shouldn't be committed to any idea of natural necessity in the world or to any notion of objective modality. And I make that distinction because you could, someone like David Lewis, who's just mentioned, he believes in objective modality. He thinks it's an objective fact what the maximally strong and maximally simple trading off versus strong scope theory is. So he believes in objective modality, but it's not natural necessity. But Bass doesn't want either, I think it's right to say. And it seems that scientific realists tend to agree with Bass that the scientific realism requires some kind of realism about modality. And that was certainly what I took to be the main lesson of his stuff in the development of my own views. But in Nancy Cartwright, her realism associated with realism about singular causes and powers. Anjan Chakravarti and Alexander Bird, scientific realism goes with realism about dispositions, powers. Now, I'm not sure what to say about Michela now after the last talk, but I took it that she thought that that science gives us modal knowledge in the sense of knowledge of objective modality, and maybe I'm just wrong about that.
No, that's correct. Modality of phenomena. Correct. But not in the... We'll talk about later.
Okay. Now, Ron Geary first suggested that you could get a form of scientific realism by conjoining kind of the constructive empiricist view about the aim of science with some kind of modal realism. And I cited that in my first paper when I introduced this idea of ontic structural realism. Ontic structural realists emphasize how science represents modal structure, by contrast with what Van Fraassen called in the 2006 paper, structural empiricism. And so I very much think of my realist view as defined by contrast with Van Fraassen by a commitment to objective modality. Now, I use the term modal structure as an abstraction, right? So lots of people think they know what causal structure is and nomological structure. And I just say, yeah, well, let's take the genus and causal structure and nomological structure as species of modal structure. That's all I mean by modal structure. Now, I went around saying modal structure for ages, and people would just stare at me. What on earth do you mean by that? We have no idea what you're talking about. But nowadays people are talking about modal information and everyone seems to think they know what that means. Well, okay, fine, just talk about modal information then. I'm not too bothered, right? You don't have to use the word structure, that's not important. But if you think that science is telling us about modality in the world, then I would call that a commitment to science telling us about modal structure. That's how I phrase it. So there's various philosophers, some of them here, who have used this idea of models giving us modal information. And so this is part of my homage to say, look, scientific realists seem to have accepted Van Fraassen's idea that if you want to be a realist, you've got to be a realist about modality, and they've set about trying to elaborate that in various ways. So what do I mean by it? Let me just have one quick go at saying so. So we capture, we make successful predictions of measurable quantities on the basis of our theories. Insofar as we do that, we might think the theories capture the modal structure of the world. Example, the solar system. So think of the data being the positions of objects in the night sky on the celestial sphere. Right? Now, if I have a data model, just a model of those positions, you might think it captures modal structure to some extent insofar as it can be used as a basis of prediction. Right? So it's part of my data model. I can look and sort of go, oh, well, I bet there'll be a full moon in 28 days. I've made a prediction on the basis of my model. So in a minimal sense, it might capture modal structure just by capturing a projectable regularity. But now, Simon Saunders, in a paper that was very influential on me, can be thought of as a sort of proto-structural realist paper, he says, well, actually, you can think of geocentric astronomy as capturing modal structure because you can think of a possible geocentric model. For every heliocentric model, there's some very complicated geocentric model that kind of approximates it. Now, think about a geocentric model. It's surely capturing something about the modal structure of the world because it's predictive, right? But there's lots of elements of the model that we don't think of as representing anything in the world. And in particular, we don't think that those elements represent the causal structure that's responsible for producing the phenomena, right? Epicycles and deference, we don't think of those as real circular motions that produce the regularities that we see, but they're part of the model. On the other hand, oh, and I've just mentioned, by the way, I mean, it's not just about prediction, but also counterfactual inference. I think most scientists would accept the Earth's orbit would be less stable without the moon. There's tidal locking between the Earth and the moon, which was pointed out by Newton. It explains why we always see, the dark side of the moon isn't dark, right, as we all know, but it always faces away from us. And that's because of tidal locking, and that makes the Earth-Moon system very stable, makes our orbit stable. It's good for us. And the counterfactual that we get from Newton's theory is if there was no moon, the Earth's orbit would not be so stable. And the thought is that that is preserved in general relativity. So the whole mechanism of tidal locking just carries straight over to general relativity because you get back the relevant features of Newtonian gravitation as a low energy limit. Okay, now Kepler's model of the solar system is heliocentric. So I say, look, this is how, if you want to get a grip on the idea of modal structure, here's a bit more modal structure now. Because Kepler's model, any heliocentric model, says that Venus and Mercury should show us a full set of phases, like the moon, when viewed from the Earth. And to a realist about modal structure, this isn't an accident. Right? The reason those planets show a full set of phases is because they're inner planets. And that's because of the way the world works. It's causal, it's nomological, it's modal. However, Kepler's model only represents kinematics, so it doesn't capture the same modal structure as the central force model of Newton. So in Newtonian physics, we have the force of gravity, which makes the orbit of Mercury not exactly elliptical, but Kepler's laws remain a good approximation. Okay, good. So that's supposed to give you some idea of what might be, and then a Newtonian theory doesn't get the full modal structure because it doesn't tell you that gravity propagates at the speed of light rather than instantaneously and propagates by waves, like general relativity says. So we can have the idea that a model can capture some of the modal structure in some ways, but not all of it. And that's my attempt to make sense of the idea of modal structure for you. So I suggest that, you know, models can encode modal structure. But of course, I've already got all that. And I'll just skip over that. Right, and so, you know, the essence of the no miracles argument, I think, is that there is modality. Right, that it's the reason why we think it would be a miracle if the theory was so successful, if the objects or whatever didn't exist, is because of the causal powers or the laws that we think the objects obey. It's not the objects on their own. There has to be modality there for the no miracles argument to get off the ground. So, yeah, we think, realists, that successful prediction and or manipulation is indicative of accurate representation of modal structure. But Bass says, no, natural necessity or any kind of objective modality is just a projection. Now, for both Bass and scientific realists, what counts as our best science is to be specified by the theory choice of the relevant scientific community. And Van Fraassen agrees with the scientific realist that science is exemplary of rational inquiry and it's progressive in respect of empirical adequacy. And debates within science about what theories to accept are about what is best for the discipline in the sense of what will lead to empirical progress. So I think we can all agree about that. And the thing I think we can also agree about, and I refer to Bass's earlier talk where he used the idea of concordance from Weil. I think concordance is a rough synonym of triangulation, which is a rough synonym of consilience, which is a rough synonym of robustness, which is a rough synonym of convergence. I mean, the rough idea is more than one line of evidence leading to the same result, but I'll clarify how that can come in different forms in a bit. So let's think a bit about real scientific practice and empiricism and whether it's vindicated by it. Now, the ultimate case study in the scientific realism debate is atomism. And the ultimate experiments in the history of atomism were those of Jean Perrin from 1908 to 1913. And I think the proximate locus of the no miracles argument is Perrin. That's what realists really, that's the paradigm of no miracles for them. And many philosophers of science have been very influenced by Perrin's example. Carnap and Reichenbach took them to show the importance of the convergence of independent measurements for theory confirmation. For Smart, Putnam and Boyd, they illustrate the no miracles argument and inference the best explanation to justify belief in unobservables. For Penelope Maddy, the experiments show that atomism is not only empirically adequate but true. She says, and this is a quote that Van Fraassen quotes in a paper that I'll come to in a minute. I hope you will like the pun at the top there. Because Van Fraassen talks about, in that paper, he talks about the law, the realist law. And the law here meaning, you know, myth. Right? Maddy makes the astonishing claim that there are atoms was actually empirically adequate before Einstein and Perrin, and afterwards it graduated to another status. Now, in this paper, The Perils of Perrin in the Hands of Philosophers, 2009, Bass finds, he re-examines the Perrin case. And he says, look, you realists have got it all wrong. It really supports empiricism. And what I'm going to say is, I sort of partially agree, right? And I'll say in what way I agree and what way I disagree. So Perrin's law seems to be that realists always get what Perrin did wrong. And Van Fraassen says, look, Perrin actually, what he really did was make atomism empirically respectable by determining Avogadro's number and resolving various anomalies. Sorry, I didn't finish my slides there. And here's this quote from Bass. To properly credential the theory, the procedures that count as tests and measurements in the eyes of the theory must provide an empirical grounding for all its significant parameters. The completion of this task which made the kinetic theory into, at least in principle, a truly empirical theory, was Perrin's real achievement. Now, I'm not going to demur at all from his re-examination of that case. I think he's absolutely right about it. But what I want to do, and here's the quotes you already had this morning. This is vile, expressing this idea that this is what we need to be able to do. We need to be able to determine the relevant parameters empirically, and we need to get the same values for those parameters by different methods. So what I want to do in the time I have remaining is to have a look at atomism, in a missing part of the story of atomism for lots of us, which is chemical atomism. There's kind of two routes to Perrin, one through Dalton to kinetic theory, and Maxwell and Boltzmann and Gibbs, and the other is through molecular structure, and that's chemistry, not physics, and it's less well known, and that's what I'm going to talk about. So Bass says, the debate between, I think this is a great quote from this 2009 paper, the debate between empiricists and scientific realists is not over the reality of unobservable entities, but over the telos of scientific activity. Then Bass says, do scientists in practice make the distinctions so familiar to philosophers between what is true and what is good for the future of their enterprise? Between, on the one hand, counsel to doubt that they're atoms, and on the other, counsel to doubt that the atomic hypothesis points to the good direction for the advance of physics. Well, and this is a really interesting question to think about. I think you can get some support for the idea that some scientists did make the distinction between whether to believe in atoms and whether the atomic hypothesis is good for the discipline, right? Arguably, and this is a point Oliver Darrigol makes in his book about Boltzmann. In the 19th century, there were lots of people who thought there were tiny particles. This is a great point from Bass's book, where a scientific image, where he says, the unobservable, observable distinction is not the theory, non-theory distinction, not the theoretical, observational distinction, because the phrase tiny particles too small to see, that noun phrase refers to unobservables using no theoretical language, right? Now, I think lots of people in the 19th century, if you ask them, are there tiny particles too small to see, they would have said yes. Now, that didn't mean they think atomism was a good way to do chemistry, right? Why not? Because they thought that these tiny particles too small to see were empirically inaccessible. And so it didn't matter that they existed, they weren't relevant to doing science. And I think this is some support for Bass's view. And furthermore, I think we can sort of say a bit more about this. So the laws of stoichiometry, they actually start with the law of conservation of weight. Right, that's the first law of stoichiometry. Then there's the law of multiple proportions, definite proportions, multiple proportions, and reciprocal proportions. Roughly, there's nitrous oxide, NO, and there's nitrogen dioxide, NO2. There's no NO 1.5, right? That's the point of these laws. Things combine in whole number ratios. Now, the atomist has an explanation for that, and the anti-atomist doesn't. So, if you believe the kind of inference to the only explanation line that you get from scientific realists, you might project yourself back into like 1820 and be like, right, the laws of stoichiometry, I believe those. The only explanation for them is atomism, so I must believe in atoms. But that's not, in fact, how scientists behaved or thought. And that is, therefore, support for Bass's view, I think, right? Because the point is, having the only explanation was not enough. So why? Because it was possible to interpret the empirical adequacy of the theory entirely in terms of equivalent weights. So here in Sweden, which did so much as a country to contribute to the progress of chemistry, Berzelius invented the modern chemical notation that I just referred to. He had superscripts instead of subscripts, but it was basically NO2. Lots of people just interpreted that in terms of like how much by volume or by weight of one thing did you need to mix with another. And so there's this idea of equivalent weight. And they say, look, you don't need to believe in atoms, just believe in equivalent weight. And sure enough, because of that, many chemists did not believe in atoms, even though they used these formulae. And again, I think this is something of a vindication of Bass's view here, right? And, you know, if the realist is right, maybe we'd have to say, a certain kind of realist is right, maybe we'd have to say that all the chemists who didn't believe in atomism immediately after Dalton were irrational. I don't think we want to say that. There were also problems with atomism, as Bass points out, that there were various anomalies. So, you know, Wollaston complains, you know, you have these three parameters, you can't determine them all, and that violates the prescription, the empiricist prescription, that we should be able to determine all the parameters. And Bass says, how did this situation change? And talks about more theoretical hypotheses and so on. Okay. Well, before we go on to talk about other bits of chemistry, let me just point out that although Van Fraassen claims the mantle of empiricism, and though there's a strong sort of skeptical and anti-metaphysical tradition in empiricism, and although some empiricists formulate their view in terms of appearances to the senses and so on, and we can think of Hume, Mach, and Van Fraassen himself here, there's another tradition in empiricism. And this can be called the methodological or experimentalist tradition, according to which empirical adequacy, yes, but observable means measurable, not anything to do with the human senses. And indeed, these kinds of empiricists emphasize overcoming the human senses. And so someone like Nancy Cartwright, I think she would describe herself as an empiricist, but also a realist. And in that tradition. Now, Bass earlier mentioned this, the Newtonian response to the Cartesian critique. You know, we must be able to determine the quantities that you're talking about. Well, yes, but not necessarily by observation in the sense of unaided human senses, but using instruments. And indeed, it seems that science has made progress by eliminating the senses in favour of instruments. So the last line there is supposed to be, empiricism has transcended the human senses. Overfull box is one of the things I get told most often. So, have I got to finish soon? How long have I had?
30, you have
15 minutes, okay. So I'll skip over this and I'll just talk about operationalization. So an empiricist will think that we must operationalize the things we talk about in science. And if we look at the history of chemistry, I think we can see this very directly. Weight was operationalized with the balance. And of course, one of the most important things that was required in the history of chemistry was to make those balances very, very accurate. Right? You know, in the 18th century chemistry, people who were chemists also invented new kinds of balance because they needed more accuracy. So Cavendish, Lavoisier himself. Pressure became measurable with heliometer. Temperature with the thermometer, heat with the calorimeter. So one of Lavoisier's great achievements with Laplace is to invent the calorimeter to make very clear the distinction between temperature and heat. That comes from Max Planck in the about 1760s. So operationalization, yes. Empiricism in that sense, yes. But now let's just think a bit about what's involved in chemistry. And this is my sort of most direct challenge, which I make in part just because I'd really like to know what Bass will say about it, not just because I want to be right or anything, you know. Because it seems to me a real problem for this view. In the 18th century, there was a massive growth in the number of laboratory substances. And a laboratory substance was something that you could make and know that you'd made. Now, there was no argument about whether these things existed, even though some of them were odorless, colourless gases. Now, you can't hear them, you can't see them, you can't touch them, How do you know they're there? Well, you could see bubbles in liquid, but does that make the gas observable? In any case, it certainly wasn't observable that it was memphitic air rather than fixed air. That's nitrogen versus carbon dioxide. So how did people come to believe that they had carbon dioxide, that they had nitrogen, and that they were distinct? Well, because you could make them in determinate ways and you could distinguish them by their properties, which often meant by their reactions. So to take that simple example, carbon dioxide dissolves in water, nitrogen doesn't. So you know that you've got carbon dioxide, not nitrogen, partly by that, but partly also by the method of making the substance. And it was very important for sort of realism about oxygen that Michela, great Swedish chemist, first person to isolate oxygen, didn't publish it, so Priestley gets the credit, but it was Michela first. Michela eventually learned to make oxygen into a whole load of different ways. And it was a very important part of recognizing its existence as a stuff was the fact that you could prepare it in different ways, but once you prepare it, it always behaves the same and it reacts the same with other things. So contrary to sort of thing you read in Kuhn, one of got to be the most overrated book in the history of philosophy of science. Contrary to what Kuhn says, there's no incommensurability at all. People have got so many different words for oxygen, right? Fire air, pure air, dephlogisticated air, eminently respirable air, right? The list goes on. No one was any confusion about they were talking about the same stuff using different words, having different theoretical commitments. So the research program of the pneumatic chemist was based on identifying substances that could be reliably prepared in different ways, considering weights and volumes of reagents and products of reactions in sealed experimental apparatus, and then reasoning about the experimental data as a whole. And this is where I think it's really important that there's actually two ideas of triangulation. One is a kind of epistemological idea. It's purely epistemological idea. Like, you tell me something and then Hans tells me it. I'm now more likely to believe it than if you tell me twice. Okay, because I've got two independent sources of evidence, right? But there's also this idea of something that manifests itself to multiple modalities of measurement. And Bass himself gives this example in his wonderful book on scientific representation of the rainbow. He says, a rainbow is not an object because it's a public illusion, because it's only detectable by vision. It doesn't feature for any other sense, right? So apply that to measurement in science, and what you're interested in is being able to access something by multiple modalities of measurement rather than by multiple senses. And that being a kind of criterion of reality. So, right, I'll just finish, I think, because I haven't got long now, by saying I think the other great challenge for empiricism here, maybe, not empiricism, for anti-realism, is the so-called second chemical revolution, which is the introduction of the idea of molecular structure into chemistry. And where that began, even though people had no idea about how bonding worked, it began in the 19th century. And I'll skip over that. So the critical thought was that you could have the same substance, you could have a substance with the same elemental composition and the same proportions. You could have two distinct substances with the same elemental composition and proportions. And so what chemists decided was that the difference between those substances had to be due to their bonding structure. And originally that bonding structure was just like a topological structure. It's just like what's connected to what. And it wasn't really thought about particularly, I don't think, in a spatial way. It's the idea of what are the atomic connectivities. So dimethyl ether, CH3O, CH3, has the same proportions and composition as ethanol, but ethanol has an OH group and dimethyl ether doesn't, and so they're chemically completely different. And actually this originated with two compounds that had the same formula, one of which was explosive and the other wasn't. And so it's pretty clear they weren't the same thing. But then later in the century, people started attributing spatial structure to molecules. And part of that story, which I'm just going to stop my slides now and just talk, part of that story was the idea of chains of carbon atoms, which was all arrived at by inference and indirect means. No possible way of accessing the atomic structures directly, but then also the idea of rings of carbon, and Kerkulé being very important there. And then later, stereochemistry, where it was realized that you could have two substances with the same proportions, elemental composition, and atomic connectivities, but one would be left-handed and one would be right-handed, and this would affect how they behaved in plane, how plane polarized light behaved when it was passed through them. And this is Pasteur, and then various other people. And so I guess my conclusion is it's hard to understand this story other than in realist terms. There's no way of sort of thinking about what was going on without thinking about there really being atoms and then being bonded. And also part of the story is that for chemists, the reality of atoms and molecular structure was established before Perrin. And here I'm indebted to a really good paper by someone called Joshua K. Brown in Synthesa on chemical atomism. And he points out that at the time when the physicists were worrying about whether there were atoms, and the people who did chemistry but were more concerned with physical chemistry also worried, but those concerned with organic chemistry and with structure were absolutely convinced there were atoms by, before Perrin's experiments, in fact. Okay, good. So, empiricism, yes. The criterion of success for a theory is empirical adequacy, yes. But empirical adequacy and empiricism should both be understood in terms of measurability rather than observability. And at least, I don't think I've remotely given any kind of knockdown argument here, but I think that it's definitely a case study that people should look at. Is, yes, we've looked a lot at Perrin, but let's look at how people came to believe in molecular structure in the 19th century, because I think it's very hard to understand what was going on without taking the kind of realist commitment at face value. But if all that's right, and you really believe everything I've said, well, actually, that's a problem, because I really do overdo it with slides, don't I? I'm always worried that I haven't got anything to say. But, that's it. But then you could believe everything I said, and then you say, okay, right then, so there are chemical bonds then. And then that's the question. Because in the 20th century with quantum chemistry, some chemists attempted to say there's no such thing as a chemical bond. And so unless we've got some way of squaring that circle, then it looks like my argument for realism is a reductio. So I'll stop there.
Thank you, James. So we have at least 10 minutes for questions. Hans.
I'm wondering so I like this measurability twist. I'm wondering though if you think that measurability always ultimately eventuates in observability, in some sense that so I would think measurability is something like there's an interaction such that I can reliably observe sort of the end products of that interaction.
Right, good. So that's kind of the obvious objection, is like measurability just means making an instrument and then there's a position of a pointer and then you use your eyes to look at the pointer, right? So I think the really important point is that is invariance with respect to the human senses. That is, yes, I could make a pointer, but I could also have a weighing machine that speaks my weight.
Yeah.
Right?
Yeah,
So now there's a kind of invariance with respect to permutation of the sense, right? So therefore it's kind of incidental to the output of the scientific process that it delivers a particular kind of sensory output in the end, because that wasn't the important thing. So I have a paper about this, which I think Bas doesn't like very much, but called I can't quite remember, but the talk I was giving was making sense of senseless empiricism, because I like a pun. And it's a paper in Synthesa where I kind of take up that I say more about that answer that I've just given.
Okay.
Can we have Paul? He put his hand up first.
We will have Paul, but first we'll have James.
Oh, sorry.
And then Michela.
Thank you. So I was wondering, is there anything selective about the empiricist realism that you arrive at? Like, is there any sense of hesitancy? Is there part of the theory that you do not take the realist commitment to once it becomes measurable on multiple dimensions? And there's, I guess, two ways I could ask you in particular this question, which is also why you were happy to collapse your use of the term modal structure with just modal information in general. So there seemed to be less of an emphasis on structure.
I know, but I just don't care about the word structure. I mean, so many people get hung up on that word. I mean, I don't understand how you could have structure without information or information without structure.
Well, you could have information about things.
No, but I mean, what I mean by structure is to have information, you've got to have some sort of quantity that you know, some sort of quantities or something, and then that's a structure there because you've got relative. You know, what is a quantity? Well, it's some sort of position in some ordering, you know, and that's a structural thing. So, I mean, you know, or if you just take the basic idea of information, well, you know, as in information theory, you know, you can't have information without structure. What does that mean? I mean, you know, for Shannon's channel or whatever, it would be weird to say, yeah, it's a channel that carries information, but there's no structure to it.
Is that a finger pass?
But about the point about others. I mean, I think the question of whether or not, I don't think we have to think that everything in the theory is representational. I think that's especially true with physics. My point about the theory of molecular structure is that when you attribute a ring structure to benzene, it's not really like you've got a mathematical model or anything, right? I just don't see how you can take that as anything other at face value. But of course, if you were talking about a gauge theory in particle physics, then you might think, oh yeah, there's things just like epicycles. There's things in the model that don't represent anything in the world. So I'm not arguing for any kind of like, you know, we should be a realist about everything or anything like that. Yeah.
Sorry, Michela and Paul, I'll let Bas jump the queue here. And
I'll jump in. Okay. I would like to follow up a bit on Hans's question. Okay. You know, the word observe in English has two different linguistic functions. There's the transitive verb observe, like observe a match or observe a table, right? And then there is observing that something is the case. And when you try connected or disassociated observability and measurability, you were talking about the second function of the word observe. So by measuring something, you establish that something is the case, like a quantity has a certain value, okay? And that is a much more complex subject than observing that. and observing it, right? The transitive verb observing. In the basic things about constructive empiricism, the distinction between observable and not observable in the first sense of observe is important and is made. But the discussion of observing that is connected with the theory-ladenness of language and the involvement of concepts and theories in how the judgment is made. So I don't think there's a very simple contrast between measurement and observation in that sense.
Right, interesting. But I sort of take on board your points in your paper about the theory itself telling us what's observable. I sort of think about that in terms of measurability, like in the context of that example from the Newtonians replying to the Cartesians, it seems like we can talk about measurability of the mass there.
Yeah, and we can talk about direct measurement of the acceleration and theory-guided measurement of the mass ratio.
Right.
And so the direct measurement involves rulers and rulers and clocks, right? Eventually, in more fundamental physics, like Weiling and Eddington insisted that the only relation that should be kept for direct measurement is coincidence. Okay? Notice that this has nothing to do with the limitations of the human senses. The rulers and the clock, if at the level where the rulers and clocks are admitted as direct measurement, yeah, well, we have to see where they are, obviously, or see the pointer of the position of the pointer. But when it comes to coincidence, you are beyond the point where you're saying, what can you see, what can you touch,
Yeah. I guess I'm thinking about chemical practice. I think it was measurability that people cared about, and that it was only measurability that could establish the existence of the things that they were treating as their kind of objects of inquiry, the laboratory substances. So you could distinguish carbon monoxide from hydrogen, both being colourless, odourless, flammable gases, by their specific gravity of carbon monoxide. Hence it was called heavy inflammable air, and hydrogen was called inflammable air. So,
but in each of these examples, you have to carefully look at which measurements are theory guided and which are direct measurements.
Right. Yeah. So I think. Okay. I'll think more about that.
Michela.
Thank you.
Sure, yeah. No, thank you, James. That was really interesting. I guess is that time of the day where I started kind of thinking about where we are. So we started with Kyle, that gave us, started his talk with a waffle, and with this idea of the von Fraassen talking about observability, and now we conclude the day with kind of qualified defense of realism, I suppose, by replacing observability with measurability. And I was just wondering whether you can say a little bit more about the rationale, as you say it, for this view of realism as some sort of ontology. So realism is ultimately, I was struck by your first slides, right? If you're a realist, you believe that there are all those objects. You ask questions about what there is, ultimately. This is what realism is. Which I'm not saying is wrong, I'm just saying, what's the rationale for upholding that view? Because I personally abandoned the view a while ago, and in a way that's what I find the commonality with empiricist view like Bastiaan although you may not like the expression epistemology, I think, his project wasn't a project in the epistemology of science. And so it wasn't really a metaphysics first approach. It's a project that starts asking questions about how is knowledge possible and how we use models to latch onto reality. And once you go that way, then obviously you can take different metaphysical stances. You can go empiricist, you can be, I don't know, anti-realist, you can be realist. But it seems like you don't start with this kind of starting point, which is a metaphysical ontological one. And I kind of had the impression you were starting with that. So you started with realism as a view about what there is. So you can ask questions about, is there phlogiston? Are there chemical bonds? Are there atoms in paren?
Right.
And so I was just curious about yeah.
So let me try another example. So is it observable that there are gases? I mean, so in the 18th century, everybody ended up agreeing that common air that we're all breathing is a mixture of different gases. So it didn't matter if you were Priestley or if you were Schiller or if you were Lavoisier. They came to think that common air is a mixture. Well, you could only think that if you arrived at the view that there were gases, right? But gases, I mean, that's an ontological commitment, and gases, to my mind, are not directly observable with the human senses, any more than heat or temperature are. We have some sort of access to temperature and heat with the senses, but if we directly observed heat or directly observed temperature, it wouldn't have taken thousands of years of scientific and cultural evolution to make the distinction between heat and temperature. And my claim is that the distinction between heat and temperature is fundamentally an operational distinction between two different kinds of measurable quantity. And that's kind of foundational in the scientific practice, as well as the idea of the existence of different kinds of laboratory substance. And as well as the idea that, to say something like common air is a mixture of gases is to make a claim, it seems to me, about the unobservable. Because I can't directly observe that common air is a mixture of different gases. So I think what I'm suggesting here really is that quite a full-blown realism becomes foundational to chemical practice way before anything like atomism becomes foundational to physical practice.
We'll let Paul have sorry, Michela, and we'll have the last question from Paul.
Okay, thank you. Yes, I was very pleased to hear that you're bringing chemistry into this story now. And I would think I would very much like to see the details of the evolution of this atomic debate, so that the reasons for believing in atomism were it's far more complicated than just Perrin. But just on some of the details of the chemistry, I've never really understood why Dalton's claim that substances comprise atoms explains the law of constant proportions.
Yeah.
I mean, I just don't understand. Well, Berzelius's objection to Dalton was that Dalton doesn't give any explanation of chemical combination, and that's the interesting question in chemistry. Well, how it is that substances combine, and there's no. Well, it's not merely that there's no trace of an actual explanation in Dalton. He's supposed to explain the law of partial pressures, which is based upon the idea that atoms have a caloric atmosphere which enables them to repel one another. Okay.
I take your point. So you should look at this paper by Joshua K. Brown, because he replies to what you just said in a long footnote. I mean, replies to you. He says, well, Paul Needham says he doesn't understand why Dalton gives us an explanation, and then he gives his reply. And I'm just going to repeat what he said, which is roughly that I think you can explain even if you leave things about your explanation unexplained. And so I think the really interesting thing about the theory of bonding in the 19th century is that there were a whole load of things that people accepted, like there can be single, double and triple bonds. All these kind of statements one can make about the theory of bonding. And yet all of those things were accepted at a point where people had no idea how bonding worked whatsoever, right? And in particular, the big problem they faced was diatomic homonuclear molecules, right? Because everybody thought that bonding was something to do with Berzelius proposed this theory that it was positive plus negative charges. But that doesn't work if hydrogen is H2. Okay? So until you have electrons and electron pairs and Lewis, you can't understand, you cannot possibly understand what bonding is from our point of view now with hindsight. You look back and say, it's no wonder they couldn't understand what bonding is, right? Because it takes a lot to really get it. So I think I agree with Joshua K. Brown that you're asking too much of the explanation, that even though the explanation leaves some things unexplained, it still explains more than not having anything at all. But yeah, I refer you to his paper because he engages with you quite a lot.
Yes, look, there's a lot of things I could say now, but I mean, I'm not at all happy with that. But could I just mention one other point, and then we can follow the details of Dalton later on. But when you talk about stereochemistry,
yeah,
I mean, this is a similar point. You mentioned that stereochemistry explains the rotation of plane polarized light, which was the first observation which led to this distinction between the stereoisomers.
Yeah.
I can't understand how merely pointing to the idea that there are atoms explains this. As far as I understand it, the first attempted explanation of this was to, Fresnel had an explanation of calcite's rotation of in the 1830s. The problem was to get that into a molecule. And I don't think that was done until the beginning of the 20th century. So merely to say that plane polarized light is rotated differently by these stereoisomers it's not an explanation. The first attempt to explain this is to give a physical mechanism that actually shows how the rotation works, and this is the classical thing is based upon Fresnel's theory, and then of course there's the quantum mechanical explanation.
If I reply, I'll just repeat the schema. I'll reinstantiate the schema for my last reply. So I won't convince you, but I take your point.
In that case, let me ask you to join me in thanking not just James, but Richard, all the speakers, and especially Bas for this wonderful afternoon of talks.